All right, hello there, Newegg viewers across the internet. We're streaming on a variety of different platforms, but we're going to be checking out some chat, making sure that you guys are a part of this conversation because the embargoes have lifted.
They are.
It's the talk of the town.
Talk of the webs.
The exciting internet discussion happening right now. AMD X570 Ryzen 3rd generation, and I could think of no one better.
Oh, thank
to
you.
help walk us through this. JJ, thank you so much for dropping by.
As always, man, it's awesome to be here.
Not only to chat AMD, of course,
Yep.
because I'm sure ASUS has some fun products to help
Just a couple. Maybe just
out.
a few.
A couple. It's been known to happen, some good support. But again, that entire X570 family, that new lifestyle that we're going to be talking, Team Red, AMD, and we've got a lot to cover.
Yes.
This is a pretty substantial upgrade.
Yeah, so I mean, for anybody that's, of course, checked out the channel in the past, checked out the different streams, you know, I think we've pretty much done a stream every single time that AMD has come to the table to introduce a new series of processors and a new series of chipsets. And so it's definitely been an evolution and a revolution in a lot of ways in terms of what AMD's been bringing to the table. And I think now for their 3rd generation, right, we're seeing some real impressive design and engineering and innovation that they're bringing forth. This 3rd generation part, they're kind of taking it to the next level in terms of their architectural refinements, where for those of you who kind of know what AMD's been doing in terms of Ryzen and the core Zen architecture, right? We had our Zen Plus, and now we're going officially into Zen 2, even though we're in the third generation of the processors. But this Zen 2 really does quite a bit to not only, I think, extend the performance, the power, the efficiency, the scalability, and really lay just an amazing foundation for enthusiasts, content creators, for gamers, for anybody that's really looking to be able to build an amazing system. Some really cool stuff. So I think we're going to be talking about that. We're going to be talking about the core chipset. Of course, we're going to be talking about motherboards, and we're going to be fielding questions. But hopefully, I think at the end of all of this, you guys are going to be able to have a really great understanding and foundation, you know, surrounding the latest and greatest from AMD and from ASUS, and definitely, of course, making your experience that much better when you're shopping here at Newegg to be able to kind of figure out what's going to be the right board for you, what's going to be the right CPU for you, and ultimately, what's the right platform for you to pick.
Yeah, I woke up to a bunch of disappointed tweets. You're like, oh no, I slept in. I should have stayed up late to get my order in. But no, I think it's going to be, I'm glad that we're doing this conversation with you. Just some of those little nuances, some of those clarifications. I don't think any of this stuff is difficult, but it was funny, like I was doing the sit-down interview with some of the AMD product reps, and I was very politely corrected to not say Ryzen 3. That this is Ryzen 3rd gen.
3rd gen.
And again, because we're talking Zen 2.
Zen 2 architecture.
So I think that's probably the best place to start.
Yeah, for sure.
Because we're talking, and again, so many people are excited. I've seen so much crazy traffic surrounding the new benchmarks coming out, some of the reviews. Obviously, we're into like week 0 reviews for people, and I feel like this is going to be one of those evolving stories as people get more comfortable with this hardware.
For sure.
But let's chat out some of the major differences as we're looking at 3rd generation Ryzen, these 3000 series processors. I think immediately what I'd like to jump in on is the fabrication process.
Sure.
And talking about that die shrink.
Yeah, well, the die shrink, I think, is definitely a huge part of what AMD's been able to do, and we'll definitely show you guys, I think, a couple of slides here, how this translates into, of course, what you're going to be expecting in terms of kind of performance. But AMD is incorporating a brand new overall fabrication process for the CPUs for this generation, so they're going to something called a chiplet-based design, and by incorporating a 7 nanometer lithography process for the core CPU, and then a different, actually, lithography process for the I/O die, it's giving them that agility and flexibility to be able to do some impressive stuff. And ultimately what that translates into is going to be, I think, a couple of key aspects. One is the IPC uplift, the ability to be able to integrate more cache, which of course is also going to translate into games performance, and then improvements in terms of floating point. For those of you that aren't always as familiar with some of these technical terms like IPC and floating point, ultimately what AMD has just really been able to do is they've kind of gone from almost the bottom all the way up to the top and looked at all the different avenues that influence the performance of your CPU. And by looking at those, they've said, as we can now scale up frequency, which isn't something that always increases when you drop down in terms of the nanometers, they've said, okay, how can we then go ahead and improve upon these different aspects? So some of these things were like they, increased the actual bit for the Infinity Fabric, right? They added new prefetchers, right? They've got, these improvements in terms of the clock cycles. They've gone ahead and made modifications that work in conjunction with operating system updates. All these things ultimately translate in that if you're talking about single thread performance, multi-thread performance, you're getting a significantly better experience. And an experience that I think the great thing is that you're seeing it across all these different SKUs that are going to be available, right? Because while this is definitely, I'd say, a mid-range chipset, right? AMD, of course, has higher-end chipsets with the 399 based chipset. X570 is in that mid-range. It's also kind of breaking a new ground in a lot of ways, is that the scalability of this chipset, this chiplet-based design is now allowing you to go to such high CPU frequencies that you can kind of start off on a pretty high-performance entry-level side of the kind of build, and you can go all the way up to a pretty high-end build all on the same platform.
It's really interesting for this generation Ryzen, seeing how AMD has run right up against the bottom tier of Threadripper.
Sure. Yep.
For this type of design, where now, of course, I mean, obviously there are a lot of people already talking, well, next-gen Threadripper,
right,
talking about what we've got here. But this goes far beyond. I mean, what you were talking about in terms of the entire chip's sort of evolutionary process, 7 nanometers is kind of a lazy way to just describe what are some pretty significant architectural changes that we've seen from second gen, I almost said Ryzen 2 to Ryzen 3, from second gen Ryzen to third gen Ryzen.
Yeah, and I think the main thing that's the most important is that it's just, what AMD's been doing here is essentially leveraging the right technology and the right lithography to be able to maximize the scalability for this processor's design. And so there's a lot of other work that has gone into being able to really enhance the performance, but definitely 7 nanometers is a industry-leading based design implementation that is allowing them to achieve so much more within these designs. So with that, let's go ahead and just kind of like realize this in terms of what the actual models are that you're going to have available to you. So we can take a look at this slide right here, and you guys can actually see the models that are going to really be the focus for right now. So these are predominantly here. You've got Ryzen 5, you've got Ryzen 7, and then you have Ryzen 9. Now we don't have in here, but technically you could run these on these, would be, of course, the recently launched Ryzen 3 SKUs, right, which integrate Vega-based graphics. But of course, with this being a higher-end chipset, that's generally going to probably be preferred more kind of B450. So you've got the 3600, 3600X, 3700X, 3800X, and then the 3900X. And we'll be talking about a SKU that, of course, will even be higher end than the 3900X in a little bit. But that shows you what we were talking about, from that base of 6 cores and 12 threads all the way up to 12 cores and 24 threads, which is very, very impressive. I think, we already had that expectation that AMD was offering amazing multi-threaded performance with solid single-threaded performance, but with the updates that we just talked about in terms of that IPC improvement, right, the increases in terms of the cache, the refinements that they've made in terms of prefetchers, and so many other aspects in terms of the architecture that you now have within Zen 2, you're now really also significantly bringing up that single-thread performance so that you really get a great balance. Because the reality is, with these type of systems that you're building, if you're a general day-to-day user, you're a gamer, you're going to probably be a little bit closer on that side of the fence where you want more benefit from your architecture and your processor frequency on that lightly threaded side. I won't say single-threaded side, but on that lightly threaded side. We're definitely seeing game developers take advantage more, where we are seeing some titles that have better multi-threading, right? But multi-threading tends to kind of really spread its wings and really fly when you, of course, step into more advanced productivity, of course, or content creation workflows, or, maybe like professional or esports related gaming scenarios, right? Where you might be doing things like streaming or things along those lines concurrently while also gaming. And that's where I think now, with this third generation Ryzen part and any one of these parts, you're getting really, really great balance to be able to get a great experience in either one of those situations, whether you're talking about lightly threaded scenarios or heavily threaded scenarios.
This has been one of the most, I think for me, one of the most exciting aspects of watching the competition in the x86 arena taking place is how on the pulse. Sometimes you get that where one competitor is just a little off. Like they're making a product for a demographic that's maybe a little too ahead or a little too behind the current curve. And right now, this notion of enthusiast parts, gaming parts, exactly falling into that territory of I might be playing a game and using the same box to share that gameplay in real time, that these types of solutions from AMD and from that other processor manufacturer are now very, very present. Like they're in that space very aggressively, and they're executing really well to maximize that kind of performance.
Yeah, and I think ultimately the goal that we have here with what we're trying to do, as a motherboard manufacturer, the world's largest motherboard manufacturer, is to really be able to ensure that regardless of whichever CPU you end up picking, right, the core experience you're going to be able to have based on the form factor that you want and the features that you want is going to be one that is really like lock in step with all the functionality and the feature set that the architecture and that the platform allows for. So with that, let's go ahead and take a little bit of a closer look here and talk about how this will also scale a little bit further. So coming actually in September, we're going to be going even to a higher end part, which is going to be this guy, the 3950X.
I love seeing this.
So this is going to be a 16-core, 32-thread part, right? And again, just a huge amount of L3 cache, because that's one of the big changes that we have here is, of course, more on-board L3 cache. Now, an important thing to kind of keep in mind is that now that we've kind of talked about this range of these CPUs that you have available on this platform, you want to keep in mind that this required us to kind of really go about and designing a series of motherboards in combination with working with AMD to be able to ensure that the experience that you have as you keep moving up across this stack is going to be ensured. And we'll talk more about this when we get into motherboard design.
For sure.
But it's important to kind of keep this in mind that, of course, with the scaling that you have within the type of CPUs, when you're talking about, again, going from as little as a 6-core base part all the way up to a 16-core part, right? That's a lot of range, and it requires a lot of kind of design work to be able to ensure that the experience is efficient and reliable and stable for whatever CPU, for whatever CPU
you want your customers to be able to maximize their CPU purchase, regardless of how they're kind of combining with the different supporting infrastructure of the box they're putting together, which I mean, again, there's going to be a lot to dig into. So I'm really excited, especially for some of the things that you've brought for us to kind of manhandle here today. But going through, and we've talked about some of the differences in the core counts. We've talked about some of the architectural improvements. But I was hoping we could, exactly, the slide that you've got up in here for me right now. Some of these improvements here where I was actually very surprised to see some of these early numbers. I was a little nervous about this new chiplet design and how that would affect things. I'm on a 2970 Threadripper, and there are some performance concerns about memory and how you're feeding that processor. I'm very impressed with what AMD has done here.
Yeah, they've gone about and implemented, I think, a very interesting design. So with this chiplet-based design, fundamentally what they're doing is they're decoupling the memory controller. So now you essentially have your CCXs, your processing cores, independently housed, right, along with their cache, and then you have an I/O die, and then there's also the memory controller, which is independent, and they all kind of work through this Infinity Fabric. But the key benefit that you really have, and for users from a day in and day out perspective, how this is going to affect you as somebody that goes about when I'm buying memory for my system, or when I'm thinking about memory, or when I'm putting together the system, what does this translate into? One, the official specification support for X570 and for 3rd generation Ryzen series processors has been bumped up. So in the previous generation, it was 2933, and yes, you could technically run maybe higher frequencies. Those are overclock frequencies, and the processor and the motherboards could allow for that, right? But now we've officially moved up to 3200. So that means 3200 is your ensured out-of-box speed. So one, you get a little bit more performance there. But the cool thing that AMD has done is they've really made refinements in the memory controller to be able to also allow for much more aggressive frequencies to be reached. And so this means, 3400, 3600, 3733. These are all much higher frequencies that can be readily achieved on X570 without some of the kind of the teething pains that you might have had previously in terms of some of the specialized configurations. Now, for ASUS, we spent considerable time and effort on our trace layout, our overall power topology, our UEFI tuning to be able to ensure a great AMD experience previously, and we definitely led in that regard. And for this generation, it's only that much better. But I think the exciting part is going to be for users out there that are really kind of interested in just kind of taking it up to the next level. You can kind of either go with this really, really optimized, I'd say, pairing between the Infinity Fabric and then the DDR frequency that you're running, which would generally be, like I said, up to 3733, or you can essentially run them uncoupled, and you can change the ratio, and you can even scale to higher frequencies where, like on our ROG series motherboards, we're validating frequencies, between 4400 to 4800.
Oh, wow.
And we've already seen, fully realized frequencies beyond that. Now, it's important to note, though, keep in mind that your memory controller, it's kind of like the silicon ladder. If you guys never heard that term, there's always some variance that occurs between the product when it's released. And so, well, every CPU that gets released from AMD, along with pretty much every board, will be able to ensure, let's say that 32, even that 3600 speed, as it increases, there's going to be some variability where not every single processor may be able to hit that higher frequency, even if the board's been designed for it. So it is important to keep that in mind. But for a percentage that can hit it, it's definitely really impressive. And this is true for actually all CPU architectures, not just for AMD's architecture. But it's really impressive to be able to see, hitting 4400, 4800, 5000 megahertz, right? And like I said, we're comfortable enough that we are truly validating our ROG series boards, for 4800, and we're also talking about high memory density population. And when we get into the motherboard detailing, we'll talk about also how we've made the process very simple for users so that, there's one-touch options inside of our UEFI so that if you want to automatically define, your frequency, your timing, your voltages, it'll automatically pop that in there and get that done for you. And we'll also talk about some really cool tuning attributes that we have that allow you to optimize the experience. Because right here in this graph, if we go back to this one more time, we'll see that one of the things that's also being kind of communicated here by AMD is going to be latency. And so latency isn't something that always gets talked about in conjunction with frequency, but the latency is relevant. So we can see here, recommended configuration is 3600 CL16. And then we can see we maintain that 1-to-1 optimal ratio of driving memory frequency with the Infinity Fabric at 3733. If you kind of go beyond that, what you would ideally want to do, of course, is have high frequency and low timings, right? And so, we'll be talking later about how on some of our motherboard designs, we're able to take 3600 kits of memory that are validated for CL16, but because of our optimized trace layout, what we refer to as OptiMem, we're actually able to run that same kit at CL14. Right?
Oh, interesting.
Yeah, so we're actually allowing the memory to run in a more optimal parameter of operation. And part of this comes is that memory always has essentially room to work within, but how good is the signal performance? How much interference there might be, right? And so we've done a lot of optimization to work to maximize signal performance, right, between essentially the motherboard and the memory controller so that we can really help to allow you to fine tune that. So we'll be able to run not only higher frequencies, but tighter timings, even at lower voltages than competing solutions. So we really feel very excited that we've been able to realize a lot of performance with what AMD is doing with this next generation memory controller.
Yeah, it really seems like there's a bit more headroom for manufacturers to play in this space. I mean, obviously, there's a lot more nuance to tuning all of that than just like, oh yeah, you can jack up 4,000 megahertz, great, go for it. Because I feel like the clumsy metaphor for me would be like I'm running a really a fuel mixture that's too lean. If I've just got speeds cranked on one side, but I'm not actually getting more information through the system.
Yeah, I think the fun part ultimately will be to this is that, AMD is really committed to the enthusiast community. And so the cool part about having essentially the flexibility to have decoupling, to be able to overclock the Infinity Fabric, to not overclock it, to have more DRAM ratios, to have these things ultimately just give you as an enthusiast, as a DIY user, the ability to say, how do I want to really tailor my system to be able to get the best experience for what I'm doing, right? And I think the more options you have to be able to achieve that is always going to be better, right? And I think keeping in performance, this is another area when we talk about not only that AMD's extended the overclocking margin for DDR, but actually inherently for processor frequency. So one of the really big focus points for AMD previously was with the implementation of Precision Boost and XFR, which they refined through multiple versions. And now what we have is actually Precision Boost 2 along with Precision Boost Overdrive. And essentially what this is that the CPU has a lot of built-in technologies that allow it to kind of understand all the operating characteristics of what's occurring, from power to thermals, right, to voltage, all of these. And if it has essentially headroom, it's going to automatically extend its frequency. So this is really impressive because essentially it's like real-time automated overclocking, right, that's built into the processor. And this is actually something that even for those of you that are looking at reviews right now, it's changing. There are updates that are being released by AMD that are getting phased in terms of UEFI releases where you're going to be seeing even a little bit more aggressive performance. So even some of the reviews you're guys seeing right now aren't 100% representative of the performance that actually is going to be able to be fully realized. So this story will continue to improve and evolve over the next coming weeks.
It's really exciting to see as we've sort of maintained, because we're going to be talking about that too, is we've maintained some notion of like backwards compatibility. This socket has had a lot of life. It still has some life left in it, but that there's still a lot of evolution happening.
Sure.
I come from a reviewing more mobile background. The life cycle is as interesting to talk about as just that day zero. Here's our first run of benchmarks.
Right.
And that we're still seeing growth, and we're still seeing people figuring this out, and
how you can tune to extend the battery life,
get
how
even
you can
more,
tune to sustain clock speeds over time. And so to AMD's credit, what they really did here is that one is that they've kind of ensured a guaranteed minimum level of performance that you have, of course, with the base clock and the boost clocks. But then essentially when the automatic overclocking comes into play, when you combine that specifically together with an X570 series motherboard, you combine that together with a higher performing cooler, you're going to be getting into some pretty aggressive frequencies. And one very impressive part from AMD is that these frequencies essentially can be unconditionally sustained. Compared to some other architectures in the past, there has sometimes been kind of built-in time barometers of how fast, let's say, these boosts can occur, or essentially be sustained for a period of time. So maybe after a certain amount of nanoseconds, the CPU frequency says, regardless, I'm going to drop down, right?
Gotcha. Okay.
That's actually not the case here. AMD is essentially keeping track of all these things, and if they still see that essentially all those characteristics are present, they're maintaining that frequency consistently. So what this really means is that actually over longer and sustained workloads, you're even getting better performance because there's not a drop that's coming into play.
And you were explaining to me that...
And it mirrors real manual overclocking in that way, where normally with traditional kind of overclocking, you would fix the frequency and the frequencies wouldn't drop down.
I just, because from some of our previous conversations too, it's like what I remember is overclocking from my early like AMD Thunderbird days compared to what we have today it's a completely different animal. But you were even explaining to me that those frequency changes are happening faster and now they're being sustained longer.
Yeah, actually you make a really great point to that. So another impressive thing that AMD did here is that there's something that's called clock ramping. And so now many times when you look at your processor frequency goes, and it varies a lot. It drops down when it's idle or it's doing minimal workloads. The frequency and the voltage tables kind of all coincide, and so they kind of come down, right? And then when you're doing work or you're gaming or doing something, they'll ramp up. And that normally requires a certain amount of time to execute, going from, let's say, 1600 megahertz to 4 gigahertz or whatever that range might be. AMD now has essentially built-in technology that allows for that process to ramp exceedingly quick. It's very, very, very fast, and it's much faster than previous generations, and that ultimately gives you much better performance in a couple of key categories. One, in things like launching of applications and launching in games, because the moment that executable gets hit, that processor can immediately ramp from that idle state and ramp up. That gives you an advantage because that's also about efficiency, because it means you don't have to have your frequency fixed at high frequency always, right? You can keep it more nominal, right? And then just when the processor needs to give you a lot of performance, it's going to ramp up and give you that performance. And then when it can drop back down, it just drops right down. But it does that so quickly. And so that is a very important and impressive technology that's been incorporated for this generation. I think, looking holistically at the processor, those type of optimizations along, like I said, with the increase in cache, right? The increase in the Infinity Fabric bus, the DDR4 improvements, right? The IPC clock improvements, the fetch improvements. You can start to begin to see how these all starting to stack up and how really just such huge performance uplifts have been incorporated within Zen 2 and this third generation part. So it's pretty impressive stuff.
No, I knew you were the right guy to have this conversation with, because from some of the online conversations, you get like 7 nanometers, 7 nano. That's it's 7 nano.
Yeah.
That's what's important.
Yeah, it's
smaller.
definitely more than that.
Which is great, but I mean, like again, that this is. I always like to look at the philosophy of a brand,
right? Where
this is third generation Ryzen. We've seen them iterate and improve, and now this is an evolution, and a very important evolutionary step for Ryzen to be taken seriously as a mainstream mid-ranger and enthusiast solution, and they're executing right on the pulse. Like every single one of these improvements from second gen to third gen is something that is very appealing to a variety of different enthusiast communities, content creation, gaming, and then other types of productivity. Like there hasn't been a misstep.
No, they've done a really outstanding job, I think, at making sure that they've committed to the segments that they said were important to them, and then putting the time and work and effort into that. If we go back over to kind of this little slide right here, where we can give you kind of a little bit of contrast, so you can kind of see that example of kind of just some of the performance benefits in Cinebench here. You can see you've got Ryzen 2600 versus Ryzen 5 3600, and then you can see the performance difference between, of course, your standard and then your automatic overclocking. So you can see that just by leveraging that technology, that precision boost overdrive, right, how much it can extend the performance, right? And so this is free performance that you're going to have. And the great thing is that AMD has kind of built in an envelope performance that's assured with the coolers that come included with their processors, but it's only going to get higher when you invest in better cooling, or like I said, you pair it with an X570 series motherboard. So pretty impressive stuff in that regard. So I think with that, talking now from I think a larger level, it's not just, of course, about pure performance, right? One of the most impressive things now about CPU architecture, right, is how much it influences the connectivity and the overall I/O that you have in terms of your system, and that's because all of that is now being baked inside the processor, right? You've got PCI Express lanes, right? You've got I/O connectivity, which gets matrix from your PCI Express lanes, and so many other elements. And so here, this is where some really impressive stuff is going on with third generation Ryzen series parts, right? And I think the important part for a lot of you, right, is that it doesn't matter which third gen Ryzen part you're going to buy, you're going to get the same class of I/O connectivity. So they're all going to feature essentially this same class of connectivity, which is really cool. So the big one you're going to see right here is you've got, of course, that high speed USB where you got up to 10 gigabits, right? So that's the USB 3.1 Gen 2. You then have a PCI Express base 4 that's going to not only be part of the CPU package, right? But you're also going to have PCI Express 4 as part of the chipset, right? And then you even got PCI Express 4 that's linking between the processor and the chipset. You can see how that matrix into storage, and we'll talk a bit more about how that translates into the number of kind of SATA ports or the storage M.2 configurations you're going to have available to you. And of course, PCI Express that's going to be allocated from the CPU to your PCI lanes for your graphics card. So all the way around, the great thing is here is that you're pretty much getting an introduction to have the absolute fastest I/O standard for whatever you're looking for. If it's going to be graphics, you're going to have the fastest I/O. If you're looking for storage, you're going to have the fastest. And if you're looking for the fastest external connectivity, you're going to have the fastest. So you're not only getting this super impressive single-threaded performance, you're not only getting great multi-threaded performance, actually, if anything, even better multi-threaded performance and great single-threaded performance, but then all this I/O that's just extremely fast. So it really helps to round out the overall experience of the platform as a whole.
Yeah, definitely. And okay, good. And you've already moved. We've got different slides up that we can also see here too. That was one of the main questions I wanted to start off with, was seeing some of the early benchmarks and some of the I/O on PCIe 4 storage solutions while I was at Computex. And it does seem like we're prime. Like we have these sort of generational tipping points as, maybe this doesn't make sense as like just sort of a mainstream, I use mostly a web browser computing kind of solution. But there are so many applications. There are so many now sort of mainstream high performance situations where this kind of throughput is increasingly making more sense. And we're already building really fast storage, M.2 drives, things like that. Now it seems like we've got something that's interesting enough to push us into this next generation of storage solutions.
Yeah, and I mean, also I think the other important point to kind of keep in mind is that for storage for a long time it was really bottlenecked, right? Until we really started using NAND and getting into flash storage, everything else was getting so much faster, but hard drives were a limiting factor. And so I think over the last few years we've seen just an incredible scaling of performance from flash-based storage and SSDs in general. And so it's fantastic to be able to see that essentially we have a specification that we can introduce to help to maintain that cadence of continued performance in storage, because definitely it can still serve us to be even faster in terms of everything, because the applications we're using, they're not getting smaller. The games aren't getting smaller, right? We're running things more concurrently, right? The latency that we want in terms of the responsiveness, all those demands, none of them are going down. No. So the more responsive that we can have a system, the better, and that translates into the more bandwidth we can get, the more bandwidth we have, the more that we can give you something responsive.
I always think it's really funny, like when we get those like, oh, well, this next generation platform, we're going to eliminate loading times. Right. And you're like, no, you're just going to make the games bigger.
Right. I mean, I think we're getting to, we are going a little bit faster than, some of those advancements. So I think that, with something like now PCI Express Gen 4, these latest generation NVMe based full bandwidth M.2 SSDs, we are getting to the point that, we're putting out more hardware and the software's gonna have to catch up, but that's a good situation to be in, right? So here's just some kind of some numbers perspectives for you. This is Corsair's latest generation MP600. It's a Gen 4 PCI Express M.2 based SSD, and you can just see some just insane numbers. Now, of course, this is not IOPS. This is not, of course, your standard, more minimal real-world workloads, but at least it's showing you an outstanding representation of the level of bandwidth that can be afforded to this device, where you're getting literally almost 5 gigabytes in terms of throughput there, right? And then, about 4.2 on the right side. So just some truly impressive numbers. You compare that to kind of a more mainstream, but still exceedingly high performance traditional M.2 based SSD, and then of course a traditional HDD, and you can just see that you've got huge amounts of performance. And the great thing is that, of course, as we see the SSD controllers get refined, the technology get improved upon, these numbers are only going to get improved across the board. And one really cool thing too is that PCI Express 4, you wouldn't expect it to go backwards, but it maintains the same improved encoding scheme the PCI Express Gen 3 had. So Gen 3 was very important because it wasn't just about doubling your bandwidth, but the actual encoding scheme for how information was packaged to go through the actual pipeline. That pipeline was made fatter, but actually the encoding scheme was made significantly more efficient as well. So think about it like in video, right? You know, H.265 allowed you to actually put in much more video and have that video look better, right? So it's the same thing here. So here the encoding scheme is the same actually for PCI Express Gen 4. So we're still able to have really great efficiency and effectiveness, but we're now giving you also even more bandwidth. So it's really, really awesome to see.
Nice. And so I mean, I'm sure we'll be talking about some of this as we go through some of the other chipset situations too. But when we're talking about PCIe 4, I fear it starts to become a little bit of just a buzz term. 5G, PCIe 4. And we're starting to see some of like the early benchmarks for things like the 5700 XT. What does that mean in terms of graphics? So we're looking at PCIe 4 for storage, and we can very easily quantify you get this much more.
Right.
Are we going to see something similar for the throughput, the graphics fill for our cards on PCIe 4?
Yeah, so here we've got another slide to kind of show you the increase in the overall bandwidth that's going to be afforded in terms of graphics, and we can see right here that testing right now with PCIe Gen 4, if you run something like a simulated test, you can see just the increase in terms of the number of gigabytes that you have between Gen 3 and Gen 4. So I think the most important way to look at this data, right, going from, you know, over a little bit over 13 gigabytes, right? Excuse me, there's the frame rate, but there you have the bandwidth, right? About 13 gigabytes to over 21 gigabytes. The way that you want to look at this is that most people keep a platform for probably about 3 to almost 6 years, especially when it's a more enthusiast or higher end platform. But they will probably change their graphics cards maybe twice to even 3 times within that same time frame.
I definitely resemble that.
And if you go about that, the benefit that you have is that while right now we're just about short, we're not generally fully saturating PCIe Gen 3, we're getting fairly close to where essentially we could use more bandwidth for that next generation set of graphics cards. Looking at the candidates of performance improvements that we're seeing within graphics cards, it's pretty easy to see that, you know, probably within the next generation and definitely the generation after that, we're going to be able to saturate the current PCIe Gen 3 in terms of our graphics cards. So having a foundation afforded to us by the CPU and then by the chipset that is essentially allowing for essentially those next generation products to be dropped in and be able to ensure an outstanding level of performance and not feel like it's being constrained or capped in any way, I think one of the key benefits you're going to have. So to that graphics card, you know, I think that's going to be the big benefit is that, you know, you're just ready for that next upgrade that's going to come down. You're going to be able to ensure that you're not being constrained and you can get the most performance out of that part.
It feels good when you can buy ahead of the curve. Just to ask you to speculate for a second, because I thought I found it very interesting that the 5700 XT reviews that I've read, a lot of them have been benched on Intel systems. So would you say that in this current gen, that PCIe 4 compatibility likely wouldn't weigh too heavy on the numbers that we've been seeing for performance?
Yeah, no, I think in that part, I mean, it's a fully backwards compatible specification, so I don't think that it's limiting or constraining in any kind of way, you know. So,
but this would be something looking forward to like another next gen part.
Yeah, or I mean, I think, you know, even AMD themselves, of course, you know, they've got a roadmap for even higher performing graphics solutions, with the expectation that they've already set the foundation with this current, you know, 5700 series, right? We can expect that we're even going to get better performance from their higher end parts as they come to market, right? And of course, solutions as well from NVIDIA. You know, there's tons of systems that AMD themselves have showcased with higher performing GPU parts that are available as well. So I think that their focus is in making sure that this platform is not going to feel constrained, right?
Bottlenecked as you get into the
and that you really have that flexibility. That the expectation, I think, for anybody that's building a true enthusiast class system is to make sure that you've got flexibility at really being able to drive performance, right? And that's not only CPU performance, that's DRAM performance, that's I/O performance, that's storage performance, that's graphics performance. And so the great thing is you're covered any which way.
Just some funny comments in the live chat. We don't worry ourselves about future proofing. Of course we do. I mean, I tend to go about 5 or 6. I'm almost perfectly representative of what you described. I tend to go about 5 years with what's in the case, but I'm constantly flipping storage and graphics.
Yeah, and you know, it varies. You know, there's all kinds. The great thing about being a PC DIY enthusiast is that, you know, there's platforms and choices that really help to align with what makes the most sense for you. You're always going to have users that are on the bleeding edge, and they are going to upgrade year to year.
Yeah.
And then you're going to guys have that are on the cutting edge. Maybe it's every 2 years, you know. And then you guys, you know, more mainstream people that are on that general process, and they're like, you know, 3 to 4 years. And then you got more, you know, they might even make actually a little bit of a higher investment. They don't buy into the mainstream. Maybe they buy a little bit higher end, but they keep for a longer period of time, right? So, you know, the great thing is that having a platform like this just gives you the agility to, you know, pace it out to what works best for you.
Totally.
Right?
So I mean, I think that's a pretty good segue just to kind of lightly cover, because I hope this will also lead us into some of the motherboard discussion too. As we've talked about the actual CPUs, those actual parts. Just anything else that we want to cover on the chipset X570 and what makes that different than the last generation?
Yeah, for sure. So I think, you know, that was an important part that most of what, you know, we've really kind of broken down has generally been regarding just the CPU, the architecture, the built-in functions that the CPU is giving you. But of course, when we talk about the motherboards and X570, that's the chipset, and that's independent of that. Now it is, there's definite symmetry because they kind of get brought along to the cable, but there are some definite items of difference. So let's go ahead and take a look at this little bit of a slide, and it kind of gives you a bit of clarity here in terms of what the chipset provides, what you're getting from the processor, right, overall. So you can see right here that the chipset is also giving you, right, your 10 gigabits super speed USB, you got still high speed USB connectivity, you get SATA ports, and then you also get 16 lanes. Now keep in mind the processor is giving you 24 lanes, right? So you've got a lot of PCI Express Gen 4 that's available to you there. It is important to keep in mind that these are flexible. The ones that are generally provided from the processor, those are all fixed. Okay. But in terms of what gets implemented on a motherboard, there is going to be difference depending on the cost of the board and quick switches, the ports that are going to be enabled on that board. So that's just giving you just a rough barometer of what you can expect on X570 and what it could potentially scale up to. But not every single board will, of course, have every single one of those specs.
Yeah, those become the differentiating
right.
factors of
how
far up the food chain you want to climb.
But that's, of course, one of the key benefits that, of course, at least with the 3rd Gen Ryzen series part, you're being guaranteed certain specifications in terms of that I/O, like the PCIe Gen 4. It doesn't matter, hey, if I buy a 3600 or 3900, I'm going to get my PCIe Gen 4 for my graphics card, right? That's fantastic to know.
Yeah, that's really exciting. Again, just as sort of a democratizing
effect,
depending on what it is that you're trying to build for. So we're looking at those differences between X570 and X470. Oh, and you've already beaten me to it by putting up this slide.
So this one is just helping to kind of look at inclusively. So we looked at a little bit of a slide that showed us the processor by itself, isolated. Now here we're showing you the chipset and kind of tying them together. So we can see there that we've got the PCIe Gen 4x4 link that combines them together, and you can see everything that's being provided by the CPU and then everything that's being provided by the chipset. And overall, that just really helps to show you that you've got a comprehensive level of connectivity across the board, right? And like I said, when we get into the motherboard stack, the great thing that you'll be able to know is that you can essentially any single one of these key specifications, whether it's USB 3.1 Gen 2, whether it's PCI Express Gen 4 by 4 connections for your M.2 SSDs, or you know the fastest by 16 Gen 4 graphics for the motherboard, it will be on every single motherboard that we talk about. Right. So what we're trying to just give you guys here is this baseline of understanding that all these key specifications, doesn't matter which board you're going to take a look at, you're going to get this spec. And what's going to differentiate it will, of course, be more of the ASUS narrative points, to really help to kind of define more clearly what's your usage and how those feature sets might complement that usage, right?
Right. And sorry, just for me being slow, if you could go back to that slide for just a second. Yep. As you're going through these, so we've got an 8-speed PCIe 4 lane, and then it says pick one, 1x4, 2x2, 4x1. Those are the differentiating categories that you'd be building your motherboard.
That's up to the motherboard manufacturer. Right. And so some users kind of wonder, it's like, well, I see certain port layout configurations, right? And that's up to the board vendor to figure out because, so
why don't I have 24 SATA ports and all of these
exactly, because you have to pick, right? So, we're seeing a trend. Take, for instance, most motherboards right now are generally going to offer you 2 M.2, right? And most users, generally because M.2 is going to be the fastest performing connection, right? Most users will prefer to have PCI Express high-speed M.2 based connections, right? So that's going to take away from some of those SATA ports instead of feeding a PCI Express lane to SATA ports where they're going to be more constrained, right?
Yeah.
So it's a balancing act. There are also always certain chips that we also have to put on the motherboard to be able to enable switching between different types of I/O standards, and so that adds cost too. So you know, so some motherboards might have, you know, maybe as little as 4 ports. Some boards might have, you know, 8 ports. Right? You know, it just depends on ultimately what is it that you're looking for. But, you know, we've tried to make sure that we maximize the specification as we move up so that, you know, if you're looking to try to have as much as possible, if you are somebody that wants huge number of SATA, huge number of M.2 and my graphics, there's going to be a board for you.
Good.
Yeah.
You heard it here, folks. You want to max it out, they'll have it.
So I think, you know, wrapping that up, you know, now we can kind of bring it full circle. And before we kind of get into the motherboards, you know, just giving a little bit of context to the overall compatibility of kind of third generation Ryzen processors, the X570 chipset, and how does this kind of lay out into the lay of the land, right? Because you've got X470, you've got B450, right? And you even have some other, you know, previous generation like X370 based motherboards that are on the market, right? And how does that translate into that? Maybe if you guys are interested in just buying the processor versus buying a motherboard and a processor, right?
So this has been a major talking point in a lot of the coverage that I've seen too, is AMD is sort of leading a discussion on sort of a socket backwards compatibility. I would have to believe that ASUS has something to say about, you know, sort of compatibility as you go backwards and forwards through these different mixing and matching of parts.
So, you know, AMD has been very transparent and clear about wanting to ensure that the platform as a whole, the AM4 socket, you know, has a lot of lifespan to it, and that interoperability is a key thing that I think a lot of enthusiasts have appreciated. At the same time, when you design and develop a product, both from AMD's narrative as well as from ASUS's narrative as a board manufacturer, you have to maximize your design for the time that the part gets released, right? And so, you know, we didn't have access to a 3900X or 3950X when you're designing X470. And so, you know, kind of the perspective that we try to define in this regard is that we definitely have work to be able to ensure that you can go out and you can download UEFI releases for B450 motherboards, for X470 based motherboards to be able to drop in third generation series processors. But at the same time, we've 100% from the ground up designed X570 series boards to maximize all the benefits of the X570 chipset, as well as the third generation Ryzen series processors and the range of processors that you can scale towards. Again, remember, we're talking about going from as little as 6 cores all the way up to 16, right? So when you talk about that range, there are going to be fundamental design differences in terms of what you've kind of consciously designed for. And then there's also some more firmware optimizations. You know, when we talk about a motherboard design, in general, people talk about things like, you know, the power components. They talk sometimes about trace layout. They talk sometimes about the firmware, the UEFI, the BIOS. But the reality is that all of those things feed off of each other to create the final end experience that you have when you work with the system. And even elements of firmware tuning are hardware design specific. When we have certain values for auto adjustment policies, for how we manage balancing on our, let's say, our VRM components that are on the motherboard. Those are all conditionally specific to that one product. It's not like we can make the rule work 100% for every single product identically. And so in that regard, when we tune that, we're going to probably also try to prioritize the tuning to exist for that generational part, because that's also the most fair. If you think about it, you know, a X470 based motherboard, it makes more sense for us to prioritize the tuning to get the best experience possible from a 2000 series Ryzen part, not necessarily a 3000, right? Now, we're 100% committed to working with AMD to make sure that that stock operating experience is as solid and consistent as possible so that users can feel confident, hey, if I did buy a CROSSHAIR previous generation, or I bought an X470 Prime board, that you're going to be able to drop it in there and get it.
AMD is saying that this is something that they are sort of, I don't want to say certifying, but
Well, you know, they work in conjunction to release, you know, patches through firmware to work with us to be able to help to make sure this is the case. But again, like I said, there's dependencies based on the board design in these factors. So ultimately, I think the most important thing for you guys to kind of keep in mind is that there are definite merits to considering a board that is aligned with the generational release of the CPU. If it's done right, the best experience possible should be from that latest generation product. It will never be inferior. It's always going to be superior, right? So I think that kind of rounds us out. And, you know, and one last thing, if you guys are going to be looking for just upgrading. You know, we got a quick slide here. You're going to want to make sure to take a look and make sure to see something along the lines that says, you know, desktop 3000 ready, right? That'll help you know. And then from there, you can, of course, go to usa.asus.com and go over to the UEFI download section and download that UEFI release so that you can make sure to apply that to your motherboard and get up and running if you're looking to drop 3rd gen Ryzen into like a B450 or an X470. But with that, I think now it's time to talk about some motherboards.
I think it is too. I mean, just before we hit this, I have been really happy to see like some of those generational improvements, even when you've got X470, like maybe some of the power management and thermals do sort of lean.
Oh no, generation. Yeah, I mean, definitely we're going to get into the nitty and gritty of that, but you know, you make a good point is that there have been considerable design changes. Why? Because of course the processors have changed, right? We just talked about how all the different ways that, you know, AMD has made changes in terms of the Zen 2 architecture, right, for 3rd generation Ryzen parts. So it only made sense that as we knew that a lot of these advancements were occurring, you know, while power envelopes were staying fairly the same, but, you know, things like PBO were being extended upon, and we were going to have, you know, more DRAM overclocking capability. We're going to have higher core counts, higher frequencies. It made sense that we had to go back and redesign everything from the ground up to make sure that we're designing a power delivery solution and a board design that complements and really helps to optimize the overall experience for these latest generation processors.
Yeah, that word optimize I think is very important because like I've seen some somewhat snarky commentary about, you know, using a newer chip in an older board, and you're like, I don't understand what the frustration there is because you would have bought an let's say in a magical unicorn land where you could perfectly optimize generation to generation. You would be overbuying features that 2nd gen Ryzen never would have supported to have your X470 potentially meet up with the future demands of a chip that doesn't exist yet. So again, it's just one of those things where, again, you lovingly broke this down for me before we came on, but the difference between compatibility and optimization can mean a lot of different engineering, and this is why that pairing, the motherboard and chip together, is so precious. That balance has to be pretty fine, especially when there are so many architectural changes on that CPU. I can't imagine that the future proofing of that is
it's a challenge. It's 100% definitely one of the hardest things to achieve, and that's why also still a huge amount of credit to AMD's entire you know, IP and CPU design team that they are able to also keep everything working within the same socket. You know, so it's a huge achievement, but at the same time, like I said, there's a difference between that compatibility arc and then, you know, the arc of what you can do when you can optimize. So, and kind of speaking about motherboards, we've only got a couple of them out here. We're going to be bringing more out.
Got a bunch over here on the side.
But to give
you're
you
going to
guys
get to see all of them.
Kind of the overall expectation in terms of what you're going to be seeing from ASUS, we are 100% committed to this platform. You know, we are the largest AMD board partner, you know, and we've stood across them across all segments, you know, everything from laptops to, of course, displays to graphics cards to motherboards. You know, we've been a proud partner with them. And so, you know, they're celebrating an anniversary, we're celebrating an anniversary. And when X570 came about, we were really excited to say across the board, across all 5 of our series, we're going to be offering models, a total of 11 SKUs. We're going to be offering. So whether you're in the Prime camp, right, whether you're in ROG STRIX, whether you're in TUF Gaming, whether you're in formal ROG or our workstation series, we have a board for you. So we're going to be covering, actually, we'll cover all the boards, but we have just one of each one of the respective series to kind of go over, with the exception of our mini ITX boards, where we're going to show you both of our mini ITX solutions that we will have available. So I think first things first, we're going to go ahead and talk a bit about this guy right here. So this is the Prime. This is going to be the first board that we'll go ahead and detail here. So for the Prime series, this is our kind of our series that we really first and foremost focus to being, I think, almost an outstanding representation for ASUS in terms that it kind of replaced our previous generation Blue series of motherboards, which were known for like our Pros, our Deluxe models, where it was really kind of like the stalwart series. It was the best representation of ASUS where you knew you were getting a high quality, high reliability, extremely stable product with great innovative design. And so this is kind of the new version of that with that white design aesthetic, which is fresh, it's clean, it's modern. And we also designed the overall feature set and the specification to be complementary to, I think, the widest range of users. Whether it's content creators, whether it's advanced productivity, or whether it's gamers, the Prime series is kind of like this foundation that like, hey, this could be a great board for any type of user that's out there. You're going to get a great ASUS board. Right. So there's no kind of specific correlation where we've spent certain time and effort to design certain functions or software packages to be, let's say, more suited towards specific gamers. Like when we get to the ROG models, there's going to be software packages that really only benefit gamers, right? And here, when we talk about something like our Prime series, we've tried to hit that balance of ensuring that the experience is great for anybody that wants to build, you know, a DIY system on X570 with 3rd Gen Ryzen.
Well, and then also it's, like I said, I'm excited about those crossover parts because I find so many more consumers are becoming crossover consumers, and they don't even understand that they are doing really advanced stuff by playing a game and streaming it on Twitch at the same time while, you know, sort of in their Discord, recording footage, getting it out to a capture card. I mean, like, this is stuff that we take for granted as just like mainstream performance now.
Yeah, and I think the other part too is definitely aesthetics. I mean, aesthetics drives a very large part of people's DIY experience right now. So, you know, the fact that we do have a series that it's white, it's important because it allows users to identify and have a different experience. It does. White builds are very different feeling. They feel very bright and fresh. They also even react differently with lighting because, of course, you get a lot of reflection and refraction on kind of the components where black absorbs everything. So you tend to kind of have these darker kind of fixed bright spots in a build, and when you go to white, everything is kind of like really,
glows.
It glows. Yeah, it's got a different vibe to it. So let's go ahead and take a look here at the deck really quick before we get tighter into the board, and we can kind of break some of these things down for you. And we're also going to be kind of starting here at the entry-level series because this will help you to guys know what we're doing from ASUS kind of that is inclusive of all the motherboards. So a large amount of what we're going to really be talking about we'll define here on our Prime series, but it's going to be part and parcel as we keep moving up the stack to other motherboards. So let me go ahead and get this slide up right here. Okay. So let's go ahead and take a look right here at this slide, and this is going to be for our Prime X570. So you can see that we've got the X570 Pro, which is the higher end version of the two, and then we have the X570-P. So that's going to be a little bit more price aggressive. But I know for some people that were a little bit more concerned with kind of the price point of X570, where these boards are more expensive, definitely like the -P or the TUF Gaming are going to be good options for you to take a look at because these series is generally going to be kind of under, you're going to have this along with TUF Gaming, we're going to be at like $200, $250, whereas definitely as we get into some of the higher end Strix and ROG boards are definitely going to be going up quite a bit in cost, right? So both of these models are available right now at launch. I think actually the Pro might have already sold out, but of course more is going to be coming in stock in terms of here in Newegg, so you can make sure to hit your notifications.
Thanks for the plug.
But you can see right here just a kind of a general specification layout in terms of what we'll have. But we'll talk a little bit more specifically about some of the key design elements. But this just kind of gives you some of the design attributes you can see on high level. You can see one of the largest differences right there between, of course, the Pro and the P is going to be that integrated kind of I/O shroud. But otherwise, the identity is going to be pretty similar. And most importantly, things like the power delivery design implementations, you know, the active cooling design for the PCH, many of the things that help to ensure a reliability, stability, and performance experience are going to be identical between the two. So the differentiation really comes down more in terms of like your I/O connections or the fact that the Pro has a pre-mounted I/O shield built on board, right? But that's not going to affect your ability to ensure that if you want a fast, you know, 3600X or 3900X, it's going to be the same on both of these boards.
For sure.
Okay. So here we can take a look at a high level from the specification support. We can see that the memory is going to be the same between the two up to a certified 4400, right, which is fantastic.
That's great.
You can see in terms of the difference on VGA output, display output, the Pro has DP and HDMI versus the P has just HDMI. That HDMI is also HDMI 2.0B certified, so if you did run Vega in here, you're going to get the full resolution and full refresh rate support, which not too many people are going to do that, but for those people that do want to have that, they have that. You can also see the LAN is upgraded on the Pro model where we have an Intel 21, an AT series based gigabit controller there versus a Realtek based controller on the -P. Both are going to support M.2 based configurations. You have more USB 3.2 Gen 2 on the Pro with a Type-C based connection as well as on the back. One improvement that we will talk about in terms of the headers, they both though feature quite a bit more headers for RGB connectivity than we had in the previous generation.
Oh, very cool.
And then here's some of our specialized design attributes, which we'll get a little bit deeper into right now. You can see that probably the biggest difference is going to be our 5-way optimization, which which again is a more software, but it is software combined with hardware design, where we have some automatic kind of overclocking and profiling for fans and things like that. Not present on the P, but you can still manually tune everything, right? It's just you don't get kind of single one-touch optimization options. That HDMI 2.0B, and then from there an onboard M.2 heatsink. But still have full PCIe Gen 4, and they are still thermally isolated, so they're still going to be placed in areas where you're still going to get great thermal performance out of the part, as opposed to being like directly underneath your graphics card or something like that.
Well, and I also find it interesting, like, so like if I were to be swapping out for some of these newer M.2 drives, a lot of them are coming with their own heat shields.
Yeah, well, you saw in that Corsair, already comes included with its own heatsink, and for many of actually the higher performing current generation parts, unless you're talking about maybe like 2 or 3 specific drives, many of them don't require an actual dedicated heatsink. It's just maybe under worst case scenarios or high ambience. But keep in mind, like I said, all our other SKUs do come included with it. That's just that most entry level model that doesn't have that. So let's go ahead and get a little bit tight right here before we go into the next slide. Actually, we can take a look here at the motherboard first before we go into the slide, so I can give you guys some context. So a big discussion regarding X570 series motherboards, 3rd generation Ryzen, and of course the fact that you can support significantly higher core counts has been power delivery. ASUS has really been an industry leader in terms of power delivery design for motherboards. If you even look at our track record at the highest end of the spectrum for things like performance overclocking, right now for Ryzen, we hold in the top 10 category of the highest overclocks on the market. We hold 8 out of those 10 spots on X370 and X470 motherboards. We know how to design boards. People sometimes question whether we think we know what we're doing in designing or implementing certain designs, and what we generally have shown is that the community and users in the industry will see that the usage and the performance that we're able to put out over time proves the fact that we make class-leading designs and we know how to do that right. So here you can see this is, of course, the power delivery solution, and you're going to see this is a super large, massive heatsink array, right? And then directly underneath that are going to be, of course, all the key components, right? But when we take a look at the slide, this is going to allow us a little bit easier kind of perspective to see what we're actually doing from underneath, of course, those core components. So if we take a look here at this slide, you're going to see the first thing is that we are utilizing very high-quality power components. So traditionally, I'd say on more entry-level solutions, you would normally see the use of what are called two-stage solutions, so MOSFETs and drivers. But actually, for this generation, across the board, even on entry-level SKUs like the Dash P or in our TUF Gaming models, we're actually utilizing power stages. We're not using any MOSFET and driver two-stage solutions. The main benefit that we're going to be having by going to the power stages is a couple of things. One is going to be that they're more thermally efficient, and they're more efficient in terms of their overall performance in general. We're also specifically have designed the actual VRM array to work in conjunction with kind of the design benefit, with the design, the way that the CPUs work best. With having so many cores and having that fast frequency response, you need to have something that's called fast transient response. It's how quick the actual power delivery solution can respond to being able to provide power. But when you scale up to go to really high frequencies, that response needs to be really, really fast and quite high in terms of its performance. In previous design generations, some implementations would utilize something called a phase doubler. The problem is that if you add certain links into the processing chain, just like anything, the more links you add into a chain, you add latency. And so we didn't want to have any doublers because that added latency. And so maximizing the use of power stages, we actually have what we're called a teamed approach. We're actually using multiple power stages which work in conjunction with a phase. That means we have more than one power stage working in concert. So we actually have a teamed approach where we have essentially these multiple power stages working in concert to provide that power response. That gives us that benefit of having really fast transient response and also much better thermal balancing. And what we mean by thermal balancing is that your VRM as a whole can get hot spots. And so some spots can be hotter than others. And when you have more components like doublers and other parts like that, you actually can have more pooling of heat in other areas. And so we've actually measured which one was clearly better. And we were able to clearly measure that this type of design solution actually allowed us to run at a far lower overall temperature for the VRM than utilizing a doubler-based design. So that's the reason why we have this type of design implementation, because we feel that not only is it going to be the most responsive in terms of transient response, not only is it also going to allow us that best power delivery in terms of ensuring very fast and adequate and high quality power, right? But it's also going to ensure the best thermal stability across the array of the VRM. So that's very important.
And please correct me if I'm off here, but it does seem that with this product launch, that conversation around power stages has been a more forward-facing conversation than in generations past?
I don't know. I mean, for
like I've been
Newegg viewers, you know, we've always covered in depth our designs,
Definitely.
and I think that maybe that's because that's been a pride point for ASUS, is that we've always felt confident in our power design implementations. I think there's more conversation just because the CPUs are scaling up to be higher end, so there's maybe more discussion regarding what's going on. But definitely from ASUS's perspective, we're not doing more.
This is where you guys are.
This is where we were at in the first place, because we wanted to ensure that the experience, as it's always been, like I said, even with previous generations, we're putting something that users can feel confident. For the board, in terms of what are called your inductors, or these little blocks that you have here on the motherboard, your inductors, those are fully alloy-based chokes, so that helps to give us a high-level amperage output capability. Then in terms of the actual heat sinks themselves, we're doing something that we introduced a little bit ago, and still a very unique point for ASUS across all of our motherboards, but it's what we call a two-stage contact design with a high-quality thermal pad. So normally this heat sink, when you look at a motherboard, only makes contact with just power stages or MOSFETs and drivers. So that's only one point of contact for heat dissipation. But in our design, we're actually helping to make contact across two different portions, the inductor as well as the power stage. So that helps to maximize the actual heat that we're pulling away from the VRM. So not only are we using more efficient base components, we're doing better load balancing across those components, but then we then also have a more effective thermal implementation, right, to actually be able to pull away heat. And then to further add to that, all of our motherboards, including, like I said, the entry-level series boards, are featuring a 6-layer PCB. Now, normally PCB count doesn't get talked about too much, but it is actually important. It influences a lot of different aspects of the overall performance, interoperability, compatibility, and even thermal characteristics of the motherboard. So with a 6-layer PCB, what we've definitely noticed when you go into these higher-end CPUs, you know, that have more cores and are definitely overclocked and under heavy sustained loads, right? So imagine like simultaneously gaming and streaming, you know, doing extended renders, right? Anything where you're heavily loading that CPU, we notice a significant temperature reduction by moving from a 4-layer PCB board to a 6-layer PCB board. So again, thinking in mind that maybe somebody will buy even a Dash P, but might put in a 3900X or 3950X, we wanted to be able to ensure a stable and reliable and cool experience across the board. So again, all of those boards are going to have that 6-layer PCB and the minimum of this type of power delivery solution. Now, as we go up, the power solution is even going to get better. It will even get better than what we have right here. But at this baseline, you're going to have a great experience. So
a dependable sort of experience even from Prime.
Yep, exactly. And then the last kind of power point is going to be the actual contact itself, the connection that we have for the 8-pin power connection. So this is something we introduced again a few years back, and we've continued to do it on our high-end kind of mid-range and definitely our HDT centered boards, but we actually utilize a high-quality interconnect that we call our ProCool power connection, where we actually have a solid pin. And that solid pin essentially helps to just maximize the overall thermal performance characteristics and the current output. And so that ProCool power connector essentially allows us to move up from traditionally saying that that kind of connection would be rated for about 380 watts, or we can do easily over like 420 watts, right? And it also has less thermally prone to heat up, because you're reducing the resistance of that connection because it's making actually better contact. So pretty much all the key areas that you look at in terms of a power design on the motherboard have been improved to be able to ensure that you're going to get great stability, get great reliability, and great thermal performance. So, and any one of those characteristics, like I said, even if you're considering something like a Pro, like a Dash P, or when we get to TUF Gaming, you know, our more entry-level solutions, you can feel confident you're going to have a great experience with those parts.
That's a great transition. Let's start talking about some of those. We want to move on to the TUF Gaming.
Not yet.
We still have.
Yeah.
I'm sorry. We do have the other slide up here, right here.
Yeah. So here's just a little bit of information that kind of shows you just kind of that 6-layer PCB that we've talked about and kind of how that affects, like I said, the thermal characteristics and the improvements that we can have there. The 6-layer PCB was also very important in terms of helping to ensure the best performance possible for signaling for PCI Express Gen 4. Kind of a little kind of inside point is ASUS is very, very happy to be able to state the fact that we have our own internal analysis and validation team for PCI Express Gen 4 that we can do. So sometimes you can certify something, but it's not necessarily a true certification because it hasn't been actually truly analyzed and validated. And so we're very excited to say that across the board, we feel very confident in our PCI Express Gen 4 interoperability, compatibility, and performance because of not only the 6-layer PCB, but because of our ability to do that signal analysis and validation internally across all our boards. Of course, here, we talked about that you've got the layout configuration on both these boards where you're going to have the M.2 from the CPU, which that's on the top, and then you've got the M.2 from the chipset on the bottom.
Nice.
Right? But like I said, both PCI Express Gen 4, but keep in mind the one from the CPU is never going to be constrained or limited. That's always going to be a guaranteed set of lanes, right? Anything always from the chipset has to sometimes contend with the fact that you've got other I.O. being pushed through the chipset, right?
For sure.
Here you can see an integration of the HDMI 2.0 and then the integrated I.O. shield there on the back, right? And then of course USB 3.2 Gen 2 with Type-C connectivity. On the Pro, of course, you also get that actually Gen 2 header that's actually physically on the motherboard for the latest generation of chassis, where on the Dash P you won't have that header. You still have Gen 2 connections physically on the back, you just don't have that header.
Gotcha.
Right? Yeah. And now, so this is an area that if we take a look physically at the motherboard, but you can physically see it here in this slide a little bit better. There's been a lot of discussion regarding fans, right?
It's a super hot topic.
Yeah.
You see what I did there?
Yeah.
Super hot
that was
topic.
A good one. That was a good one.
Especially here in the live chat.
Yeah.
We talked about this offline. There's sort of a common groupthink around design, hardware, implementation. We start agreeing on a certain way of getting something done.
Yep.
So we've seen fanless motherboards for a long time now. I feel like there's a vocal consumer concern about seeing a fan on these parts again.
Sure.
And obviously, this is something that I think we can address with the very solutions that you've got.
100% agree with you. I
thermals.
think, for the most part, we generally have come to the expectation that we haven't traditionally seen active cooling on motherboards for a while. Some motherboards have had it. I mean, even actually on X399 and some of our other platforms, we made it a conscientious point on X399 to state that we put active cooling, let's say, in the VRM because we felt it was a guaranteed way to be able to ensure the best stability and reliability. And so, again, here, I think the biggest concern people when they ask about the overall kind of inclusion of a fan is it going to be reliable? So I can definitely tell you, one, we've taken great pains to be able to source a part and include a part that we feel very confident in terms of its long-term reliability. So first and foremost, speaking to reliability, the fan that we're utilizing has been closely sourced from Delta, leading manufacturer of very reliable fan solutions, and it utilizes a superflow bearing that's rated for 60,000 hours in terms of its operation. Because of its inherent design and its self-lubricating based sealed mechanism, it allows it to also have significantly less vibration and a very smooth tonal characteristic, which is also important with something like a fan. So we think that when you begin to kind of measure the aspects of what you're trying to accomplish with this active cooling, right? One, you're looking for stability and reliability, you're looking for minimal acoustics, right? And you're looking for good thermal performance. We've kind of checked off each one of those things to be able to ensure that you get a great experience. And again, this type of fan solution that we're talking about, the design that I'm going to be conveying to you is the same across all of these boards that we're going to be talking about. So you don't have to worry about like, oh, do I need to buy the ROG board, or do I need
skimp? Did you skimp on the Prime? Is that what you did? Is that how you save money?
No, the solution that we're utilizing is the same between the Pro and then what you would get on the CROSSHAIR or the Strix-E. What doesn't matter. They're all going to be the same. But we have also gone ahead and tried to combine that together to be able to maximize other areas. So if we take a look actually at the slide, because you'll probably be able to see it a little bit closer here, you can actually see there that we actually have a housing and then a shunt-based design. So there's actually a heatsink that has fins, and so the airflow glides across, right? It flows across that heatsink, and that actually then goes directly to the adjoining M.2 drive.
Nice.
So not only does the M.2 drive have its own standard heatsink, which is what we expect, but we can actually help to pass over some airflow to that, even helping to maximize, right, the performance for that PCI Express Gen 4 based M.2 SSD. So we've tried to kind of combine them together. The other important part too is that the fan curve, we've carefully calibrated the fan curve that in the vast majority of situations, it's going to be operating clearly underneath 25 dB. So in most situations, it's going to essentially be inaudible, right? Yeah. If you've got any type of light audio from your system, other components, whether they're lightly humming or whether you're listening to anything on speakers or headphones, you're not going to hear this. It's not a part of you.
I was going to say, if your GPU's cranking it all.
Yeah, you are not going to hear the solution. So overall, across the board, you can feel confident and reliable that you're going to get a great experience. But you can see here, this is just another which way that we've really kind of reinforced the cooling experience, right?
Definitely.
We talked about, the 6-layer PCB board, the thermal efficiency of the power components that we put on board, right? The dual contact, large, high quality heat sinks, right? This is all about ensuring that on a platform that has this much performance, you're going to get a stable, reliable, and cool experience.
I'm glad you addressed that before I had to ask, because the common joke in our live chat has been the RIP my ears, that the one little fan on the motherboard was going to have such an impact on the acoustic performance of your system, which, considering everything that's going on in the system, I had to believe probably wasn't the case.
Yeah, I mean, definitely, if you go back to, 5 years ago, sometimes, fans, they would run like at a fixed high, like 5,000 RPM or something like that. Right. And distinctively, the tone could be very audibly heard, right? Even if it wasn't necessarily super loud, but the pitch was noticeable.
Exactly.
Right, but like I said, the characteristics of the Superflow bearing, I think, are really, really great, and acoustically, they're very solid. For me, I'm somebody that's very kind of conscientious of a lot of these things. Like I said, I'm not concerned with it at all, and you guys can be very confident in the long term in terms of the reliability and the experience that you have with it.
Yeah, I mean, you can definitely trust that, because JJ and I have had a number of conversations about our favorite DACs and amps and headphone solutions and portable music players. Like, I trust his ears. Like, he's got a pretty good head on his shoulders for audio.
So moving from there, keeping kind of in the realm of kind of cooling, fan connectivity and controls is always an important part. With high-end builds, most of the time, most users are probably dropping in somewhere between probably 4 to 6 fans into a system, right, along with all your cooling solutions. And so all these boards are going to be featuring our Fan Expert 4 technology. And so that essentially, to break things down simply, just means 3-pin fans, 4-pin fans. It doesn't matter. Connect them to the board. They're going to automatically be detected. They'll work optimally. We have calibration and profiling, meaning at the click of a button in the UEFI or in the software, we'll figure out the fan speeds from a minimum level to a maximum level. You can then use targeted profiles like silent, which will turn off the fans and just wait for them to ramp up, which is great for like web browsing, looking at pictures, watching YouTube videos. You don't need the fans to run. Yeah. But the moment I jump into a game or the moment I jump into an application, of course they can ramp up, and you can customize the fan curves. We've got dedicated headers for AIO pumps or for water pumps, and all that is built in. And the other, I think, really cool part is that we do have temperature input mapping still, which means that you can map from different temperature sources. So if, let's say, you have your front intake fans, you can have those respond to, let's say, your graphics card temperature as opposed to the CPU temperature, because your CPU might actually be maybe like 65 degrees, but your GPU might be 80 degrees. So it actually makes more sense to have your fans respond to hotter running parts or points in your system that you have a conscious concern about, right?
That was actually the hardest part of my current build, is like I went in there with thermometers at one point, because like I've got a pocket. And so I'm redesigning my fan layout, my input out, my airflow, my case flow, because like I was getting some shockingly high ambient temperatures in this one chunk, and I was just blowing air all around it and not through it.
And so it's great, because in that type of configuration, you can kind of just be more targeted and more precise as far as how you want to control things. Moving from that, and moving into an area that I think a lot of users are always interested in is going to be aesthetics. So here, of course, all the boards still continue to offer ASUS Aura Sync, really industry-leading option when it comes to RGB controlling, connectivity, and synchronization with all kinds of stuff, memory, graphics cards, SSDs, fans, everything,
has the
right?
RGBs,
but the cool thing that we did for this generation is all the boards at a minimum have at least one new second generation header. For many of the boards, they all at least feature multiple headers, but we have a new second gen header, and this new second gen header actually has the ability to detect the number of LEDs that are present within that device. And so that actually allows us to have far more accuracy and synchronization precision for when you go about control. And so this is kind of aligned also with our next generation update that we'll have for Aura software called Aura Creator, which will offer some very extensive granular control to kind of per RGB lighting. That update will be coming later, probably in around Q4 of this year. But even for current generation offerings that will be coming out with partners that kind of can take advantage of this automatic detection for second generation addressable parts, it's a pretty cool implementation. And like I said, at a minimum, there's at least one of those headers on the board.
Awesome. Excellent. Good.
So on the audio side, so somebody that can appreciate audio, like myself here.
We have to talk about
it. We continue to have our high quality audio design. So this is Crystal Sound 3.0, so it means we've got full audio isolation on the motherboard, audio shielding, we have audio grade capacitors, we have a depop filter in there, an integrated amplifier. So very, very good quality audio experience. Again, like I said, with this type of system where music, movies, games, you're doing workflow production, whatever it might be, you can have a really solid audio experience just built onto the motherboard. And so that's, of course, become kind of part and parcel. We were the first to design and implement an isolated based audio design on motherboards. It was on ROG first, and then kind of went out to other motherboards, and now the industry has kind of picked up on this. This is the best way to implement audio designs.
Oh, for sure.
But we still feel that at ASUS, we're doing best-in-class designs across our motherboards featuring these type of design implementations. So if you care about audio, you can just feel confident you're going to get a good experience.
Yeah, I've been very impressed with what you guys have done with that Realtek chipset.
Yeah, I think the main thing too that we're trying to do there is that the tricky thing that sometimes people kind of negate normal codecs for without kind of fully understanding is that the codec can have a theoretical level of performance, but it can be influenced by many other factors.
Everything else going on,
and so your goal is actually what you're trying to do is to take apart and have it hopefully get the closest to it being able to perform at its peak level of performance, as opposed to being influenced and bring down its performance and have it be subpar or not being as good as it could be, right? So when we talk about kind of the board here, there are some kind of just cool general kind of DIY elements that we've got. So we talked about one is that we've got the integrated pre-mounted I/O shield that's on the motherboard. That's of course very easy to see right there. This doesn't just make it easier for you to build a system, but it also actually gives you the benefit that when you do have a pre-mounted I/O shield, it actually gives you better EMI and ESD performance as well. So it's actually safer. It produces a more reliable system when you have the integrated I/O shield.
Also, you don't slice your hand open like I did back in the day on my old AMD.
Yeah, and there's nothing to forget, right?
Yeah.
Nothing to forget.
So made it to the end of a build and like, oh,
I didn't put in the I/O shield.
I didn't put that stupid panel in.
Right.
Oh.
Another one, it's going to probably be a little bit hard to see, but it's going to be like right here is that we have our QLEDs. So our QLEDs are 4 diagnostic LEDs, and then we have them color-coded so that when you're building the system, you can get an easy kind of visual notification to let you know whether you might have a CPU initialization issue, memory-related issue, graphics card-related issue. Just kind of makes the process a little bit kind of simpler and easier to work with. Down here on the motherboard, if I can see it right here, right there, that is a new header that we have. And it might just look like, oh, it's a USB header. It's actually what we call our node header. Okay. And so this is a brand new header that we recently introduced on a previous generation series. And the node header actually gives you the capability to have low-level control and monitoring with different types of items that ASUS is producing, as well as partners. So examples might be like power supplies or chassis, which have integrated control options. You'll actually be able to see direct readout of frequency, voltages, timings.
Oh, great.
But you won't just be able to see that information, you'll actually be able to control aspects of operation. Cool. And it'll happen directly on a low level through the actual board. So it's a very high performance, kind of enthusiast-oriented connection that's specifically being put onto these boards. So it's a pretty cool option there.
That's really cool. Yeah. I had one of those old breakout boxes that would give you those system stats, but it felt so limited. And I'm getting some information, I'm really not getting granular detail, and then I can't do anything with it.
So here it's just giving you more flexibility, more control. You'll see also that we have, of course, the safe slot design. So if you kind of take a look at the PCIe slot, it's, of course, that metal slot. Our design is a little bit different than some of the other companies where we actually use an injection molding technique. So it's actually kind of comes fully together. It's not just kind of a piece of metal that might be on the periphery of that actual extruded plastic. We actually go through all 3 axes. So all 3 axes, their shear force gets improved. And so we have much, much better performance when you talk about the rigidity of the actual connector itself.
Because I just upgraded to a 2080 Ti and I'm super nervous about SAG.
I mean, the reality is, I'm not going to overspeak to that part because I've never had a slot that's failed on me. And that where we actually originally designed this type of design implementation was the fact for people that do move their systems around.
Yes.
So sometimes maybe you're taking it from one place to another, or maybe you're doing like LANs or stuff like that. Having that design can have you feel more comfortable and confident that if you're moving it from one point to another, the rigidity and stability is very solid.
But I think you'd laugh. I did put in the little placebo stand.
Okay.
The little.
Yeah.
Just to kind of brace it.
Yeah.
So I'm super safe.
And the last point right here is that, like we talked about here in the memory design, here we've got some really nice T-Force Delta, some white RGB-based memory, but these do feature our optimized memory design, and we'll talk more about our newer Optimum memory design, but you still get very, very good quality DDR4 memory performance on this board. So the Prime Foundation, really, really great choice, like I said, for general users across the board.
It's looking good.
Yeah.
I like what you guys are doing there.
So I think from here we can go to TUF Gaming.
Here, you vamp for just a second because I got to reach.
Yeah, so I'm going to go ahead and swap this guy out here.
Do you want to trade me?
Yeah.
I'll put him over here so we can keep him a little safer.
Okay.
Perfect.
And we're going to have our TUF Gaming here. And so the really cool thing, for those of you that aren't as familiar, I think most people should hopefully be fairly familiar now with TUF Gaming, but it's still a fairly new line from us. We used to have previously just TUF, which was around for quite a number of years. But TUF Gaming is now formally part of our gaming portfolio, where we have TUF Gaming, ROG STRIX, and then formal high-end ROG. And so with TUF Gaming, really the core goal here was to be able to, again, have something like the the Prime series, where we focus on stability and reliability, but have a more aggressive price point, so kind of allow for an entry-level offering from ASUS in the gaming segmentation with a gaming aesthetic that's present, gaming software feature set that's focused towards gamers, but at a more reasonable price point, and without some of the, let's say, higher end specialized features and functions, which a first-time builder is not going to use, right? So like an example might be, on this motherboard, you're not going to have dedicated water cooling headers, right? Well, why? Probably because somebody that's building the system is not going to have a custom water-cooled loop, right? Or you're going to maybe have difference in this board is not going to have 8 SATA ports, probably because then also an entry-level builder is not going to use 8 SATA ports, right? Or it doesn't have dual LAN on it, right? Because again, maybe as a streamer, I want a dedicated LAN for my output, and I want one for my local connection, right? But again, somebody in this situation might not necessarily have that. But you still get a very great experience. So if we kind of just quickly go over, we get still high quality power stage, power design with that teamed base design that we talked about, two-stage heatsink based design implementation. We get the 6-layer PCB board. Of course, the aesthetic is going to look a little bit different, where we got a little bit edgier, a little bit more gamer centric. Still predominantly monocratic, but you have a little bit of that tough gaming color accent in there that I think still looks nice. That also works well because we do have something called the TUF Gaming Alliance, where we've worked with many partners. You can see right here for the DRAM, we've got this TUF Gaming Alliance memory from Team Group, but you can get coolers, power supplies, chassis, fans, pretty much everything that you could for a system. The difference with the TUF Gaming Alliance, though, is it's not just branding. We actually have to go through a qualification process.
You certify
and
parts,
so that really helps to make sure that as a first-time builder, like if I'm buying any one of these TUF Gaming Alliance products and putting it with another TUF product, I kind of can know that they can just all work together, right? And so that's a really, really nice factor. Even things like traditional tower heatsinks, we have a required what we call clearance zone that the partners have to adhere to, so that before we put a TUF Gaming Alliance cooler being certified, it has to adhere to the clearance zone that we've already defined for the boards. So a lot of little factors kind of get put in mind there. For this board, we're going to have 2 SKUs, a Wi-Fi version and a non-Wi-Fi version. In terms of the Wi-Fi implementation, we'll start off on Wi-Fi models, giving you a minimum of 802.11ac or Wi-Fi 5. So that's going to be a 2x2 base connection. Still very high performance. You can have very low latency, very high throughput, 160 megahertz channel support, multi-user MIMO support, beamforming support. So it's pretty much been flagship performance before AX came out. And once AX and Wi-Fi 6 came out, that now became kind of the entry. So you're getting pretty much a best-in-class Wi-Fi implementation short of AX. So very, very, very good Wi-Fi based design.
This stuff cycles fast.
You know, so you pretty much have everything that we talked about there on the Prime. So I'm just going to quickly just kind of highlight some of the key differences right here. So we can take a look here at a slide and just kind of show you the difference. Here you can also see the RGB lighting zone there in that bottom kind of right-hand area. It's a little bit more subtle than some of the sometimes other boards that might feature a little bit more, but still think great-looking boards right there. Here you can see the Wi-Fi based model. Right, and you can see there the kind of the I/O connection, right? Pretty much everything is straightforward in terms of the same connections, just one has that wireless connection and one doesn't have that wireless connection. Right? And you can see this one features, of course, the M.2 heatsink, whereas like the Dash P didn't have the M.2 heatsink. You still get the same class as far as the RGB headers, including that 2nd generation header that we talked about, right? And the Type-C connection here.
So with the difference between like a gaming focused TUF product versus Prime, just be some of the refined, like some of those differences in I/O and...
No, so actually, so like here, the first one that we're going to have is going to be partially in the TurboLand software. So this is our Packer Priority software. So normally we have more optimizations here specifically for games. And so, of course, that's, again, a little bit more gamer-centric function, right? TurboLand is the same software that is on the Prime series, though, and it can be used for anything. So if I wanted to prioritize Skype or Google Hangouts or my web browser or, you know, a video-on-demand service, you can do that. But that is one area that's improved upon. Another area is actually going to be the audio design. So while both of these feature, so Prime and TUF Gaming feature the isolated audio design, the sound package is entirely different between the two.
Okay.
So here we actually have a custom DTS audio suite which has specialized profiles. So we have an area mode, a soundscape mode, and tactical mode. And so like tactical mode has special profiling that's been balanced for, let's say, FPS-based games, right? Or you've got for RPG and action, or for RTS and MOBAs. So there's a different kind of audio experience that's been set up here. You're still getting the same kind of high quality audio design, but the software experience in terms of how you can customize that is very different between the two, right? And so that's where we differentiate a little bit more, saying that the gaming software, right, is what makes it, along with, say, the gaming aesthetic, right? But of course, the Prime can still equally be a great foundation for a gaming
system. It's just, I'll say I have a lot of fun with those tactical audio modes. You get that hard stereo panning, you're like, I know exactly where you are.
Yeah. So that gives you a little bit of perspective on what we're doing with the TUF Gaming. And like I said, this also, like I said, to recap here, very, very good foundational board option if you're going with something like the 3700X.
Right.
Because again, high quality power delivery solution, good thermal dissipation performance. If you want to build that kind of that bang for that buck, Ryzen 3rd generation X570 gaming build, really, really good option. Still get Wi-Fi on there before you get into now what we're going to talk about, which is the Strix gaming series.
Dig it. Oh, that's over here on the side. Here, trade you again. This one's a bit more of a reach. Trade you.
All right. So here we definitely can see that we're now stepping it up quite a bit.
Yeah, that one looks fancier.
It just looks in a whole nother league. So Strixes are really our kind of enthusiast mid-range product. It's, I think, really perfectly primed for the X570 series of users, right? It really kind of starts to bring in a lot of the things that users really, really like at this price band, in terms of they get really great aesthetic, really great premium design throughout, and just kind of, you're starting to also get those little subtle things that they seem subtle, but enthusiasts begin to really kind of appreciate in a lot of different ways. So, right off the bat, you're going to notice a couple of things. The heatsink got massively enlarged. So it was already very solid heatsink design that was on the other boards, but here we go to a much larger heatsink, and this one also now incorporates a heat pipe on this. So this is the actual Dash E. We will have 3 total SKUs, and we'll go through a little bit of the deck here in a moment, but you have the Dash E, which is the highest end model, then the Dash F, and then the Dash I. And so actually you can, we have the Dash I here. That's right, it's already right here. But we can bring it in a little bit here. You guys can see them kind of both side by side, but we'll have the Mini ITX and then the ATX base version.
Slide it over?
So,
okay.
So we've got both of those models, right, in terms of that. And there is also, though, improvements in terms of the quantity of the power stages as we're moving up to, let's say, the Strix boards. You've got more power stages than you have in TUF Gaming or you have in Prime. So again, while the class of the power delivery on all of them is very good, you're going to be able to ensure an outstanding experience even with the highest end CPUs. If you're talking about wanting to be able to have just a little bit more thermal efficiency, right? So less impact in terms of the overall thermal characteristics on the VRM, going to the board that has even a little bit higher end components is just giving you that. And so kind of a nice way to think about it is like, if you had like a Noctua U12S versus a Noctua U14S, both really great coolers.
Good stuff.
And one's going to be, like, okay, under load, it's like 80 C, which is very good. That's still way off from 105 thermal junction, but maybe the other one's like 76, right? Some users just feel even a little bit more comfortable. Both are really, really great running, but that one just gives me a little bit better thermals, right? And it gives me a little bit better performance.
Well, and especially from that user that's starting to recognize those limitations or those needs when they're putting their system together.
So here we've also upgraded the ProCool power connector. This is ProCool 2. It's a 2nd generation, so we have a little bit of refinement where we actually have, let me see if, I don't know if you'll be able to see it on camera there, but I can show it to you right here. And then if you, do you have the Prime board?
Yes.
So if we point right here, you can see that it's actually now contained in even a more advanced.
Do you want me to kind of hold it?
Yeah. So we can see there, you can see actually the metal on that ProCool connector. And then if we go to this 8-pin. Right there, you can see how that one's just black, right? Mm-hmm. So it's been upgraded on the Dash E board. Here, of course, you have more RGB lighting zones. On the Strix also, you have dual M.2 heat sinks on there. On the Dash E, you're also going to get an upgrade in terms of the network connectivity. So this one's going to offer Intel Gigabit Ethernet. You're also going to get 2.5G Ethernet on this board.
Oh, great.
So you've got an upgrade in that regard. You also, on the Dash E, are going to get an upgrade to a higher class of wireless networking as well. So, pretty much in all key intents and purposes, the board's going to be upgraded. But we'll go into some of the deck here to kind of show you some of the key differences between the Dash E and the F.
Because we got a bunch of them in our office right now. Like ASUS has been doing a lot of work with their router lines.
Yep.
Also to take advantage of post-gigabit.
Yeah. So, with I think the latest generation of wireless connectivity right now that you have 811AX, that was a big proponent of. So on many of the higher end boards, like starting with the Dash E and then moving into other boards, we have 811AX Wi-Fi built on board. And so that's really now moving into that Wi-Fi 6 to offer you even lower latency and even higher speeds of throughput. The great thing is that's fully backwards compatible. So of course, if you already have an AC-based router, it's going to fully work. But if you pair that up with an AX router, you're going to get an even better experience. And of course, if you pair it with an ASUS router, you're even going to get the best experience, because the cool thing about all the ROG boards that we're going to be talking about now, they all feature our game-first packet priority software. And so the really cool thing about the packet priority software is that when you open up that software on the system and it detects that there's a router there, it will automatically prioritize that device.
Nice.
So you don't have to go in and kind of configure a matrix anything. It sees that the router's there, and it can go into the router and make changes to its quality of service and prioritization schemes. So it kind of just seamlessly goes, you've got all these great components, why not try to make sure that they work the best possible? To be able to give you that lowest latency, that best throughput, and the overall best quality service. So that's a really cool level of functionality that we have built in with our game-first software. So it's here. Go ahead and just pop over to this slide, and you guys can take a quick look at between the Dash E and the Dash F. So here you can see the E, and there you can see the F. Pretty similar looking, right? A little bit difference in terms of the LED lighting zone. You can see that on the E, right, you've got you got there on the I/O shroud, right? And then you also have down there below, in between the two, PCI Express slots for your graphics cards. And then on the Dash F, you don't, right? So you can see the difference there,
gotcha,
right?
nice little highlight.
And then the F doesn't have the Wi-Fi.
Okay.
You can see right there. And then we go over there and we have the AX Wi-Fi on the Dash E, and the Dash E also has, like I said, the dual LAN, right?
Nice.
So you've got the traditional gigabit Ethernet, and then you also have the 2.5G based Ethernet. But then many of the other key specifications are going to be the same. Now this board does also feature our first generation OptiMem technology, not the highest end OptiMem, which has been optimized really for this new third generation.
Right.
This is still going to give you great DRAM overclocking, as you can see, 4400 megahertz. But under OptiMem 3, which is on our ROG motherboards, that is a key differential between ROG motherboard and our ROG STRIX series of motherboards. Okay. And so here, this just kind of gives you a little bit of a direct comparison. You can see 14 power stages, 16 power stages. We already talked about the heat sinks. We talked about the heat pipe, right, differential there as well. And then you can see all your kind of connections. But I think probably the biggest ones for a couple of people are going to be the networking connections that are on the Dash E. Is probably one of the biggest reasons why I would want to upgrade to the Dash E versus the Dash F.
Even for Ethernet, we've been in a holding pattern on gigabit Ethernet for a while. That even I just bought a new NAS, it's the first link in the chain, so I kind of overbought. But I'm looking at doing a spread on either 5 gig or 10 gig Ethernet
for sure
for my whole home now.
So having always a faster connection is always just going to give you a better class of experience for sure. So here's a little bit of a close-up shot. We can show you guys that little ProCool connector that we showed you, and we talked about already that increase in that amperage, the increase in the total wattage that's provided by the connection. Pretty straightforward. And here's kind of a little bit of a scope shot that shows you when you're talking about the OptiMem, how we improve the overall actually signal quality, right? To be able to maximize the stability and reliability, especially at higher frequencies.
Gotcha.
And so that's an important part to kind of differentiate the overall experience when we talk about high frequency memory running on these motherboards. So that if you're looking to be able to maximize the performance, having that OptiMem design is going to allow you to realize a great experience. But like I said, it's even better on ROG motherboards with the third generation version of this technology.
Yeah, that's got to be another pressing concern as we get into higher, faster, more power, leakage.
So here you can see the same type of overall active cooling design that we have for the PCH. No changes there, still the same. dual M.2 heatsinks, because like I said, higher likelihood you're probably going to get rated configurations, right, on these boards. So of course we're going to have those dual base designs. Advanced fan controls, we already talked about that, right? But here you can see just the number of headers that you have for overall control has been ramped up. So you're going to have just more total headers for more kind of enthusiast class cooling. And here we can see of course, the connectivity, where you've got the AX-based connection, the 2.5 Ethernet, and then the 1 gigabit Ethernet from Intel. Now, the cool thing here is keep in mind, like our game first packet priority software, that's what allows you to kind of go in and tweak and tune and prioritize all your network-centric service applications. So that's very extensive, very robust. It even has a fully automatic mode, so even as you launch the applications, if it senses the game's running in the foreground, it can just automatically switch to prioritize the game. Right. So you don't even have to go through and manually kind of set it up. That's like a key advantage compared to something like the TurboLand software, which is on TUF Gaming or on the Prime series motherboards. But the great thing is also it can be matrix across any connection. So regardless of whether you're going to be using Wi-Fi or you're going to be using a hardline connection, you can take advantage of that game first packet priority control software. So it's quite extensive in terms of that. And there's also like one-click profiling options, which are really nice. Like if you just want to maximize all the bandwidth and you want to eliminate everything, so like maybe you're just worried about like, I don't know if there's something else that's taking any services from me, you can go kind of like an extreme prioritization mode. So we've tried to really simplify certain aspects.
Take that, family members trying to watch Stranger Things.
Right. Well, that would be for your local system.
No, I'm just saying.
It would be for your local system. This one also features the node header, just like we talked about on the Prime series. No differential there. The second generation RGB headers too are also on this board. Now the cool thing that you step up to on the Strix series is you get 4 total headers, as opposed to on like the Prime or the other boards, you get less headers. There's 3 total, so here you're going to get 4 total, but you still get 2 of that second generation addressable header that we talked about.
Great.
Okay. And of course, you can see just the level of partners that we have across the board for ASUS Aorus Sync. Just lots and lots of partners, right?
There are a few.
So here, the audio, because it's a little bit hard to show you guys physically on the motherboard, you can see in this slide, the audio is actually even upgraded compared to what we have on the Prime series. So the main benefit here is you actually have dual op amps built on board. So this is going to be able to punch up. For most users, what you're going to perceive is going to be an increase in volume. It's going to seem louder, but it's still clean. And that op amp design, the dual implementation is great because we can do it for both the front and for the back. And we also have automatic impedance detection, which is great, so that regardless
that is so handy.
Regardless of what you plug in, you're going to be able to have like that paired experience that it correctly drives the headphone. So if you've got a little bit better headphones, that might be rated over 32 ohms, it'll help to make sure that they're driven correctly so you get a better experience. Of course, for premium users that might have, planar magnetics or really nice stuff, you're probably using an outboard amp and DAC anyways. But for probably like 75% of users out there, this type of solution is going to work really well at giving them a really great audio experience.
While climbing up is always important, I did have a friend recently blow out some IEMs because he hadn't switched his amp back down.
Yeah, for sure. That is actually a concern.
Especially with those little balanced arms. Like, you can sizzle those if you're not careful.
Oh, no, you're 100% correct there. So here's a cool little graph if you guys are wondering for some of the spec. So this is our Supreme FX S2 1220 audio codec versus the traditional 1220 audio codec. And you can see that we actually have very, very good performance, even better than the traditional codec. And one other thing that we've actually done is that we have this low dropout regulator, which helps to provide cleaner power, which is one of the ways that we can actually help to have better performance, even though we're using the same codec.
Nice.
Right? When we go to ROG will even have a higher end version of audio compared to this, because actually it'll be incorporating an ESS Sabre DAC on board.
Nice.
But without jumping too much into it, some of the really cool things that we're doing, and one of the things that really differentiates the boards, again, is going to be the software package. This is Sonic Studio 3. So the cool thing that you have here is we have really advanced application profiling and built-in volume mixing and an audio manager. So you can independently see the volumes for every single application that you're running. You can actually matrix in audio. So if you want to have audio come from one source, let's say like a web browser, while you're actually doing something else and something else, you can pre-mix that into the application.
Nice.
And then output that. You can control independent actual profiles and customization. So let's say maybe you're listening to something in the web browser, but then you go into a game. So in my game, I want to actually have maybe like an EQ mode set up for first-person shooters, but I don't want to apply that preset to what I'm listening to in Spotify.
For sure.
Right?
Yeah.
So you have the granularity that you can go in and you can have per application profiling that can be customized for not only audio presets, but for EQ. So very, very robust at really being able to tailor and define the audio experience for music, movies, games, whatever you're doing on your system.
Because I always have that moment of switching where it's like, oh, I left my tactical mode on, and now I can hear all of the sound design in this movie.
Or it just sounds horrible. You know, it just sounds
awful.
Yeah, it's just like, this doesn't make any sense.
I fired up Black Panther, and you could hear all of the little clecks and clicks of the beads in their magic interface. That's terrible. It's just weird. I've got my tactical mode on.
Yeah. And so here you can see this is the new front-end interface. It's very easy to use. You can go ahead and set everything up. And we have it broken down in 2 modes, what we call kind of like our Sonic Studio, where we have a basic mode and then an advanced mode. And then we also have kind of 2 different profiling options, one that affects more your voice, as well as incoming and outgoing voice, and then kind of the auditory experience that you have when you're listening back. So you can see there some of the application profiling that happens, the EQs that are present. You can save your profiles. We also have customized profiles that have been extended in for many popular headsets, not just headsets that are made by ASUS, but popular options from like Audio-Technica and many other companies that are out there. So
very cool. We've
done a lot of optimization to also allow you to really tailor, again, the audio experience specific to what you're going to be doing, whether you're, like I said, listening to music, playing games, watching videos, movies, whatever it might be. And there you can see how you can customize all that even towards different interfaces, which is very important because maybe, again, you want to have something on your line level output that's different from something that might be connected, you know, on Bluetooth or might be connected to a USB. And that's the power of the software, is that the audio design is predominantly most beneficial for analog line level connections, right? But of course, you might have digital based options, but maybe you still want to be able to customize and matrix those options if I'm using a USB headset. So we've looked at it from that regard to try to make sure that the software can provide a really robust experience to users of all types of sound setups. Right?
No, that's really handy. I'm definitely a more traditional audio interface kind of guy, but even I've started expanding the number of audio products just in my office between wired and wireless.
Yeah, and lastly here, we can take a look at what I was talking about, which is the virtual audio mixer, which allows you to go ahead and integrate sources from different channels. So like a microphone with maybe something else that's going on from a stream, right? So you can integrate these all simply kind of built in and a nice clean user interface. So you can definitely see that you know, a lot of users question about, you know, the value from buying a higher end product, but you can see the amount of effort that we're applying into the software experience is really a key feature into itself. So it's not always just the number of SATA ports, the number of USB ports, whether it has Wi-Fi, whether it has a great VRM design. It's also, you know, what are some of those additional functions? And definitely, I think when looking at the depth of this software, you can see that it's not bloatware, right? It's not something that's just like arbitrary and it's like, I'm not going to use this. You know, it can have genuine value for somebody that wants to spend the time to customize it and set it up and tailor it to their experience.
Sorry, I'm sorry to be laughing, but I did just review a product where it was like, oh, the main thing I can get out of this is Chipmunk voice alteration mode.
Right.
And I'm never going to use that.
Yeah, you're never going to use that. Well, like here, you know, we also have worked with DTS. This is the first series of motherboards where we'll have the DTS Unbound package, which is essentially their new DTS X, which is kind of analogous to Atmos.
Yeah.
And so there's some very advanced post-processing that's happening with this. And actually, it can be quite impressive. For people that normally don't like to use virtual stereo, I tell them, consider trying this out because the spatialization characteristics that can be set up and be applied can actually be quite nice. And can really add for another level of immersiveness and detailing and expansiveness to your audio.
I think this is going to be a huge area for audio, is getting your headphones to sound like they're speakers in space, not right on your ears.
So some really cool stuff that we have with this package that's available to you in terms of the spatial sound package that's included here in terms of Sonic Studio and the DTS.
That's awesome.
And then lastly, we've got the Sonic Radar package, which has been updated. And this is kind of something a lot of people know that we've had, which is, of course, on-screen representation of audio, right? But for the latest generation, you have a lot of options that you can go in and you can tailor what sounds in the frequency spectrum are the ones that are actually being visualized. So if you want, you know, higher tones, mid-range tones, more bass tones, all of this is very customizable and adjustable so that you can really tailor it to represent the kind of the spectrum that you want to be able to be aware of when you're in that game. And you also have application profiling because maybe the profiles that you want to have be recognized and displayed to you in something like Overwatch might be very different than might be what you want to have like in Battlefield. Because of course the sound stages are very different. The guns are different, the environments are different, the sounds that you're watching out for are different, the footsteps, everything is different. So it doesn't make sense to keep the same exact kind of recognition algorithm in place. But what you want is the ability to customize that. So you do have the ability to go in and tailor that to make sure that it works best for you.
I'm a big fan of these kind of hand-holding because I suck at these games so bad.
And as we move to the back of the board here, just some cool little DIY pushes. Of course, the pre-integrated I/O shield. We have the USB BIOS flashback. That's always really going to be nice for, of course, users that want to be able to update their UEFI on a hardware level. No CPU, no graphics card. No memory needs to be installed. You literally just need to connect the power supply, put in the flash drive, click the button, and good to go, right? Again, we've seen some other companies start to offer something like this, but this was for many years exclusive to ASUS because we designed and innovated this actual design philosophy, and we still feel that we're doing it the best here. But a great option to have, again, in certain scenarios, right? This is another cool one. We are offering something that we call the Flex Key, which is a remapping option. So chassis that still have reset buttons, the thing is most people don't use the reset button, and so we actually give you the ability to matrix this button to do something else. Cool. You can use it to maybe like turn off the aura lighting. Maybe if you just wanted one touch option to be able to kind of turn off your lighting, or if maybe you want to reboot straight into the UEFI. I don't want to hit that delete key anymore on my keyboard. I can just hit one button and it will reboot me straight into the UEFI.
That's handy.
So there's some really nice options that we've built in with the Flex Key functionality. So that, and there you can see the Q codes get extended upon in the dash sheet where we have the debug layout and then also the traditional 4-point LED diagnostic system that we have there. Okay. Let's go ahead and take a look back closer on the Mini ITX board here that we've got.
This little guy right here.
Okay. And if you want to go ahead and pick that guy up.
Yeah, for sure.
Yeah. So most of really what we talked about there is going to be present here. I think really kind of just some of the cool hallmarks to touch on this board is that this one still offers you the ability to have dual M.2 based on the motherboard. So you're going to still be able to have the chance to run 2 drives. Still an extremely robust and beefy power delivery solution that's on here. Like we talked about, our power stage design philosophy. The high quality components that are utilized on here, right? And even the high quality audio, you can even see that there's a full dedicated audio board, right? This entire section is all separated and isolated so that we can maximize the performance not only for those M.2 based solutions, but also even for the audio solution. So you can see that in this regard, that even though it's a small compact profile board, you're still getting a very high grade experience with that. So, and then of course the back I/O connectivity, if you just kind of show there on the back, you can just see that again, you've got it
pretty well stocked.
Pretty well stocked for for a Mini ITX board. There, you're not.
It's pretty well stocked in general.
You're not compromising too much there.
Not at all.
Okay.
This is a really sexy little board. I like this a lot.
Yeah, I think for a lot of users, like I said, the performance that this mini board is going to be offering for people, the fact that, like, again, remember, imagine putting something like a 3900X in here,
right,
or a 3950X. That's a huge amount of performance in an ultra small form factor board, right? It's pretty insane. I
was very impressed and influenced by some of the custom builds that I saw at Computex, where they were taking full-size cases to do this extravagant, custom water loop solutions, but then they were just cramming in these little ITX boards, and it kind of blew. Something clicked. Oh, you could do something really interesting with that space if you didn't have a full-size board in there.
So as we're getting close to the end here, we've kind of almost saved the best for last. We're going to go through ROG, and then we've got our WS series with only one board in the WS. But here, I'm going to let you hold this guy. This one is not out yet. It's going to be out in probably about a month's time. But this is going to be the Crosshair Impact. And so here again, we've really always consistently set the bar in high performance Mini ITX-based motherboards. So again, this is us kind of bucking the design convention and really taking it to a whole nother level. So we've kind of changed up the form factor. It is still technically Mini ITX compatible for the vast majority of chassis. The main difference is that for chassis that don't use a traditional GPU mounting solution where they might be vertical or something like that, you're not going to be able to utilize this board. You're going to want to go with the Strix. Right. But for a traditional Mini ITX chassis, you're going to be able to accommodate this board layout. But the main benefit that you're going to have here is, of course, you can see that this is just beefed up. Yeah. This has been designed to try to get us as close as we can to a higher-end ATX-based I'd say power delivery solution implementation, right, but on a compact board, right, and also upgrade many other elements. So you can see that when you have upgrade all these other things, you're also constrained to deal still with the space that you need for the items that you want. So we developed a customized add-on board right here using, you can see right there, this is pretty crazy. It's a custom add-on board, and that add-on board still gives you the ability to have your dual DIMM.2, excuse me, your M.2 based solution on here, but it's great for because it's easy to mount too, because you can just go ahead and pull that out, install them and then put them back on. And this also will even give you more flexibility. So this little daughter card actually has 2 of its own headers for fans. So let's say maybe you want to have 2 intake fans, or maybe fans from a radiator for water cooling setups. There's fans here, and then there's 2 fan headers that are on the motherboard. And then this also has another RGB header. So this little add-in card gives you a ton more. So you're going to have the ability to expand in terms of the storage drives, your fans, and RGB lighting, all just by adding that one little card. When you then go to the motherboard here, you can still see that we have the ultra high-end Supreme Effects audio design. You can even see, look at all the audio, all our Nichicon audio grade capacitors that are down there, right? You know, when you move over into the ROG, right? So we've moved over from, you know, ROG STRIX to ROG. And ROG, for those of you that aren't familiar or don't kind of understand the clear difference, formal ROG that is generally branded with a name, so meaning like this is like the CROSSHAIR series, CROSSHAIR Impact, CROSSHAIR Formula, CROSSHAIR Hero. This is our flagship series product. Is the best representation of what you can do in the industry, in our opinion, when you talk about enthusiast or gaming related product. It's our no holds bar to try to say, if we can innovate as much as possible with generally price not being a limiting factor, and resource not being a limiting factor, what can we do? And we try to put the absolute best that we can in terms of this product. So if you're looking for that best experience, you care the most about aesthetics, you care the most about performance, you care the most about specialized features and functions, this is the type of board that you're going to want to look towards, whether it's going to be something like the Impact or whether it's going to be the Formula or the Hero that we'll talk about there. But you can see, like I said, that Supreme Effects audio design. You've got then your headers right here that are all right angle, which are really cool. 4 SATA ports that are going to be on this board, right? You know, and then all the specialized trace topology on here. And this board does also feature the Optimum M3 technology. And so the Optimum M3 technology, the really impressive thing, I'll show you guys a little bit of slide in a little bit, is like I said, is the ability that we're going to be able to run memory essentially at tighter timings, higher frequencies, and lower voltage than solutions that don't feature Optimum M3. So again, if we go back to, you know, let's say, you know, this Nighthawk memory, if it's 3600 megahertz, right, we can maybe run it instead of at CL16 at CL14, right? Which again, when we're keeping that 1-to-1 ratio without, you know, unlinking it from the speed of the Infinity Fabric, that helps us to maximize the performance for X570 and for 3rd Gen series processors. So it's gorgeous. That is the Impact right there. But let's take a look at, I think, at the SKU that probably most people are going to be picking up, and that's going to probably be the Hero.
Do you want to trade me with the?
Yeah. The Hero is probably going to be overall for, I think, most X570 users, going to probably be the #1 board from us. And so this board even steps up to even higher end power delivery. Not only do we still keep the power stages, but you actually go into a higher class of power stages, these IR power stages. We go to microfine alloy chokes as opposed to traditional alloy-based chokes. We go to 10K rated capacitors as opposed to 10K rated capacitors, where the other boards are 5K rated capacitors. So the power delivery solution is even higher performing. The heatsink is even bigger than the other boards. You still get the high performance heat pipe. You get the Optimum M3 technology that's on this board, right? You get the great quality aesthetics. The audio design is going to carry everything that we already talked about. All those things that we showed you in Sonic Studio are exactly the same, but this board takes it further because it has an ESS Saber DAC built onto the motherboard.
I'm a big fan.
So you get just better detailing, better tonality. It opens up the soundstage. It's really, really nice. If you've got, you know, a decent pair of headphones, I'd say, you know, that $100 to about $150, even $200 price range, you know, especially with some of the new Platinum magnetics that are lower in price point, it starts to be really nice. It's a very good audio experience. You get the fully integrated rear IO shield. You can see just the huge number of just USB ports, right, that you have, tons of connectivity. You get the 811AX. You're going to have dual NICs on this one, but this one's going to, you're also going to be going in higher end when we get to the Formula. Not only do you get the 2 on here, but on the Formula, which we don't have here, the Formula will even offer 5G based onboard connectivity.
Nice.
You still get the 2 M.2 heatsinks. This one gives you 8 serial ATA ports on this board. Down at the bottom here, it's a little bit harder to see, but we have a dedicated water cooling zone. And so the water cooling zone, for enthusiasts that are building custom water cooling setups, that's going to be really nice because you get dedicated options for temperature inlet monitoring and outlet monitoring for water temps. Water flow monitoring is also capable directly on the motherboard. So that's all built in. Again, not for every single user, but for a more enthusiast user, that's really nice. Another really cool thing that maybe a lot of users aren't aware of, but we've pioneered, is we actually have an entirely different type of design present on some of our ROG boards that allows for actually much more accurate voltage representation. So overclockers are really going to appreciate this. We have actually a differential circuit design as opposed to the traditional design that's used when you're detecting voltage. So many times when you're detecting CPU voltage, you're detecting essentially a differential in the signal at one point of the output from the VRM. So that means it's kind of, the voltage is going in, and then you have to account for other things that are occurring, and then you kind of do a subtractive kind of value after it crosses through the VRM. The disadvantage is the VRM adds in some influence of characteristics and signaling, right? And that value might not be one-to-one. So let's say if you put in a certain voltage level, what you're actually being read isn't always accurate of that. And there's a lot of things you can try to do to counter and make it closer one-to-one. But ideally what you're trying to do is similar to kind of when we talked about the power stages, not having like a doubler that introduces latency, is trying to get closer to measure in the optimal vein of not having other things in the chain.
Gotcha.
And so we have a differential circuit that exists outside of the normal way.
And it's able to isolate?
Yeah, and we can measure just essentially that CPU voltage. So we can just go through that differential circuit, CPU voltage, and then we give you that readout. And that readout can be presented in our UEFI as well as in the software. And that's very close to almost being seeing what you see is what you get. So it's a much more accurate representation of that. So a lot of enthusiasts, this is a big deal for a lot of real enthusiasts when they're like, oh man, the only accurate way to get voltage measurement is breaking out a multimeter and making a specialized contact at certain contact points or voltage reads points. I don't need to do that anymore. On these, on our motherboards that feature this type of design, you can essentially rely on the software. You can rely on the UEFI to give you essentially a very accurate representation
that's really,
of
that's
voltage.
above my pay grade, but that's really cool.
Yeah. Again, for probably the most of our users not going to use it, but again, this is showing you the attention to detail of that when you buy a more expensive board from ASUS, especially within the ROG category, we have really tried to spend a large amount of time and effort to tailor the designs to be complementary to that segment. So when we say the best of the best, built for enthusiasts, built for overclockers, we want to really try to purposely design, the functions and features to complement those users and really provide them an experience that is going to be superior than already a great board, a Prime or another board.
Absolutely.
They're going to have that type of experience available to them. So that gives you some of the things here. So let me jump in here and just be able to show.
All right, catch the cable.
Oh, yep.
You got it?
While I pull up this guy, why don't you just double check if you've got anything that's
definitely
there in the stream, because I know we've gone over definitely a lot of information, and we'll help to kind of round things out there with our.
Well, right now there's sort of a back and forth conversation talking about crypto mining.
Oh, interesting.
So I think we might need to save that for a different stream.
It's a different stream.
And then also, just so you know, lots of compliments that you're looking really healthy right now, that you're looking pretty good.
Oh, yeah, for you guys that noticed my weight loss, thank you guys, appreciate it. And goal was to get back to the pre-joining ASUS weight, and I've actually done that. So
good for you.
I'm happy to do that. So let's quickly just go over here to the slides, and you guys can take a look right here.
Oh, it's pretty.
And so this will be the highest end board that we're going to be offering. This is the formula. This is the end all be all right here. Man. This is an amazing board. It's going to have the NVCM finish technology that we had in our previous generation finishes, which literally fuses a didium metal into the cover, and it just has this beautiful translucent look to it. The OLED live dash screen. It has the specialized water block built into the VRM that we've co-designed and developed with EK. It's now gone through multiple versions. Full channel wide width block, which is great for multi-loop configurations. I mean, absolutely just a beast of the board. So everything that we've talked about on the Hero is going to be present here on the Formula, but the Formula, just like I said, just goes further. It's got, like I said, that armor finish technology. It's got the 5G based connectivity, right? It's got the live dash based display. It's just premium. If you're looking to build a kind of the end all be all when it comes to a high-end X570, you're definitely going to want to be looking at the Formula. Here, the Hero is what we've just looked at, and this just can give you kind of the bird's eye perspective. Still an absolute amazing board, and I think for the vast majority of people, there's literally going to be nothing that they're going to look at the Hero and go like, man, I wish that the Hero had, because when it comes to the power delivery, when it comes to the networking connectivity, the expansion, the audio design, the fan connectivity and control, the customized water cooling options, right? The node header, all these things. The OptiMem 3 technology for maximizing DRAM overclocking, those are all amazing and they're all built in. And keep in mind that, software packages, we already highlighted on some of the software packages, but there's some really cool stuff like the ROG boards come included with a 1-year licensed version of BullGuard AV. It's included in the box. You also have our RAM disk software. So even though we've got PCIe Gen 4, PCIe Gen 4, M.2 based SSDs, you can make
your own RAM disk.
Your own RAM disk, and you
make
could
it faster.
You run a 16 gigabyte, disk straight out of system memory, and that's still even going to be faster than your PCIe Gen 4 M.2 based SSD. Here's just a little bit of a comparison between, the X470 generation and then the X570 generation. But let me go ahead and here you can see again where we're talking about microfine alloy chokes. 16 power stages, the 10K rated capacitors, just absolutely high performance VRM based array. And here's just a little bit visual representation of what I was talking about between not utilizing a doubler and utilizing essentially the design that they're incorporating for this generation, right? And here's actually some measured performance where a key thing that we really talk about is trying to make sure that the design implementation that we feature is a design that has been validated. So it's not, everything that we do is always conscientious from the perspective that when we put it onto the motherboard, we have tested it. We have an entire dedicated team of performance engineers that aren't just engineers, but they're overclockers that help to really establish and make sure that the implementation that has been selected actually aligns with the philosophy and the focus of not only our users, but what we're intending the product to be used for, right? It'd be different if we just said, let's just put this on there, but we've consciously made the decision to be able to ensure that experience is met through the best design implementation that we can have. Okay. Let's go ahead and go back out to the board here. I'm going to go through and just try to see if I can find this one other slide that I wanted to show you guys right here. And here you can actually see this is the OptiMem technology where I was talking about, and you can see an example of having OptiMem 3 where we're able to have that lower voltage, right? So you can see a kit of memory that might be spec'd at 1.35, we're actually able to run it at 1.25, right? And instead of the rated 16 CAS latency, we're able to run it at that CAS latency of 14.
I never would have considered, altering latency like that. You see that CL timing and you think, well, that's what it's going to be. Yeah.
Well, and it's very important because, like I said, many kits sometimes have the headroom to do it in, but the better the design the board, along with the better options you offer within the UEFI,
you might be able to actually
you're actually able to achieve that. And this is a key reason why people buy ROG motherboards. Is going to be the quality of our UEFI over time keeps maturing, it keeps improving. And really, we pride ourselves on really, I think, taking it to the next level to be able to ensure the options that the enthusiasts want to get that best performance possible.
For sure.
So I think that gives a pretty good roundout for ROG. So why don't we take a look at here at the last board that we've got, which is the WS.
All right, let me put this down. Grab this guy. Pass this over here.
Okay. I think we can pull out that mini ITX right there.
We can pop this guy out. All right. I always love spending a little time on this just because I don't feel like workstation-focused boards always get the same attention.
Yeah, no, for sure. So, we've talked about, of course, now 4 different series. So we talked about Prime series, TUF Gaming series, the ROG STRIX series, and then formal ROG. But our last is also one of our key divisions. Actually, ASUS is the manufacturer of all the current high-end board manufacturers, the only one that has had a long-term dedicated workstation division and even true server division. And here we actually have a fantastic board in our WS series with the ACE. And so this is the X570-ACE. You can see that it looks very different than the other boards. It's much more of a kind of focused design aesthetic that it looks fresh and modern, but at the same time, this is like...
It's a very practical.
It's built in practicality and sensibility and saying, here we've got very clean design lines, fins for the heatsink array, but still outstanding high quality power delivery solution, just like everything else that we talked about here, whether you're going to be running a 6-core or you're going to be running a 16-core. Doesn't matter. You can feel confident in the reliability, the high layer quality PCB, the expansion layout. A couple of kind of unique attributes that you're going to have with the WS model.
What would set this apart from a more gaming-focused solution?
So one is going to be official ECC validation support for memory. So in that more professional scenario, you might be actually deciding to run ECC-based memory for error correction because maybe you're going to always be under continual heavy load application utilization. So you maybe, in that situation, or even maybe professional streamers, people that are making money off of their system, where you want to really try to mitigate mitigate the likelihood of having like a crash or something like that. That ECC memory, it's not going to be as high performance, but it's going to add extended reliability, right?
Yeah.
And so if that memory in that system is, under consistent load for 2 hours, 4 hours, 6 hours, 8 hours, it might make more sense for you to transition to really having a setup that includes the board as well as the memory that's been optimized for stability. The dual NIC design, here we have a dual NIC design, but we have a higher class of NIC that's designed for specialized management options, and it's a server grade family NIC. So there are actually specialized remote control options that you have in terms of management and response options that are built into this board. That's going to be another distinction point. This also utilizes the highest end version of the chipset from AMD, the 15-watt version of the chipset, which gives more.
Another thing, I didn't realize that there was going to be that stark a division.
Yes,
that there was like
there's
an 11 watt
and a 15 watt. And the 15 watt version has more flexibility in the PCI lane assignment and allocation for how you expand on that. And so generally with WS boards, another kind of key hallmark is going to be their expanded support for different types of add-in cards. So we go through a lot more extensive validation for complex option ROMs. So you get things like specialized high-end RAID controller cards or JBOD controller cards where you're going to be running like 10 drives, 16 drives or something like that. Some of those cards are so specialized sometimes, and you put them into a normal motherboard, it might not post or might not detect it correctly because it's never been designed to recognize that card in the first place. But as a professional, you might utilize that card, and that card can be pretty expensive. It can be like $500 card. Right, but for like a normal gaming board, maybe the vendor has never gone through the purpose, which it's not any discredit because that's not a normal product that would get utilized in that.
This is fairly fresh territory for what would be a mainstream AMD part being leveraged for this kind of workload.
Yes, correct. Yeah, I mean, outside of, in the past, they've been definitely more specialized. I'd say servers that were true servers that you had that in. But yes, in the traditional desktop space for sure. And so that's kind of one of the key differentiations for people that are running these complex, multi-channel controller cards, multi-channel gigabit Ethernet cards, expansion cards, things like that. That's where you're going to get a benefit. The ISV certification, the remote management options, and then of course just the class, the componentry, and the design with WS, where it's really built for long-term reliability. Right. So great set of boards here. I think from top to bottom, kind of recapping everything that we've kind of walked through here. We've got a board that fits kind of every segment, even though X570 definitely, it's not an entry-level segment, but I think the flexibility that you have within the CPU product stack going down to something as low cost as a 3600 part, right? And even technically the Vega parts, right? Like the 3200, 3400 parts, and then going all the way up to 3950X. We've got a board across, different series, different segmentation, and different even form factors, right? With 2 mini ITX SKUs that will hopefully allow you to have, a great experience regardless of how you want to, spec out and define your X570 and your 3rd gen Ryzen gaming build.
This has been one of the more exciting talking points about 3rd gen Ryzen. Isn't just great chips. Great processors. Like, we've really seen the Ryzen ecosystem flourish over these 3 generations where one manufacturer, ASUS, is putting out almost as many granular specific motherboard solutions as maybe the entirety of the launch for Ryzen.
Yeah, I mean, 11 boards is a large amount of boards to release. But I think it speaks volumes to, like I said, like you were talking about, the community, the users, the performance, the segmentation flexibility, and overall, hopefully you guys have been able to get a good amount of information at seeing that. I think that the experience that we have, the quality of the design and the implementations, there's a great deal of consistency. So, highlighting, like I said, the quality power delivery, the 6-layer PCB, right? All those things kind of tying together the boards, but then as you kind of evolve through and you go into the higher end boards, getting more specialized and high end options, whether, it's the AX Wi-Fi, whether it's, the Optimum 3 technology, right? Whether it's the node header, right? Whether it's the dual LAN, right? All those things, it's really nice to be able to see that option across so many different types of boards. So, on our part, we're really excited. I definitely also will tell you guys that, we talked about I think the hardware designs, we talked about a lot of different software design, but one last, I think, critical part that's really important that we touch on is going to be the UEFI experience within our motherboards. And an extremely important part of buying, I think, a motherboard is the long-term experience that you have with updating that helps to improve interoperability, compatibility, stability, and performance. So somebody that I'm sure that, you look at tons of different phones, after the fact updates really affect the experience of a product.
And it's something that you don't always quantify. We get so excited about embargo week, review launch.
And the core spec that the product might have, right?
And then we miss out on those opportunities to revisit or see how these products have aged over time. Right. And I'm really getting the sense that 3rd gen, this is a long-term conversation. Like what we expect.
Even on previous AMD, we saw with memory alone, right? The amount of effort that we put into consistently patching, refining memory.
Yes.
Like I go back to that overclocking conversation that we talked about, where the top 10 Ryzen performance metrics, right, on overclocking alone, 8 of those are on ASUS boards, and there's a reason why the community selected the CROSSHAIR, both on the X370 launch and on the X470 launch, to be that long-term board that was really the best showcase for memory and for CPU overclocking, because we were consistently putting out the best-in-class support for the UEFI. So I think, again, for another platform launch, if you really not only want to get a great designed physical board, but a board that's well supported and you can feel confident in terms of interoperability, compatibility, and performance over time, and the maturity of the software, whether it's going to be in our Sonic Studio software. Again, sometimes some software vendors from some companies kind of changes every year.
Yeah.
Sonic Studio has now gone through multiple iterations. Game First has gone through multiple iterations. Our RAM cache software has gone through multiple iterations. Our RAM disk software has gone through multiple iterations. And so it's something that we've committed resources internally to keep improving and refining, right? And taking feedback, because we don't get things perfect every single time. But that feedback that we get from the community on, hey, saying, can you improve upon this? Can you refine this? Can you add these functions? Is also critical, to what we've been able to achieve in terms of the success of our boards and the feature set that we can offer you guys as users too.
Definitely. Yeah. And just so you know, we've gotten a lot of positive comments on the WS look.
Oh,
people really dig in the utilitarian look, which makes me happy, because I love a good workstation board too. You're like, oh, there are a couple more nerds like me out there.
Yeah, I mean, I think the ROG boards as a whole also have a very I think modest look. I mean, they've got very distinctive aesthetics in terms of our CyberText finishing and some other elements, but the monochromatic aesthetic is really clean amongst these boards. So again, there's no fixed colors to contend or compete with the kind of the look and feel of your build. You can really define it however you want, but there's just kind of another layer of cleanliness and refinement that the WS has, that you can see that even though they're both of these boards, when you look at them, they're both monochromatic. When you're looking at the screen, it's predominantly black. You can see a distinctive design aesthetic between the WS and between our RD series motherboards.
For sure. All right. That was so much to go through. I think that's a good place to start wrapping this up. So JJ, first of all, thank you so much.
Awesome.
I love spending the time to really dig through these, as opposed to like trying to cut together a 5-minute video that's going to sum up a bunch of points. I really like spending some time to kind of dig through what it is that differentiates these products, and then what consumers should expect.
Yeah, for sure.
I feel
I think that's our job. Our job is to hopefully make the process of understanding all the time and work and effort that we've put into. There's literally tens of thousands of people hours that have gone into designing and developing these boards, and being able to provide the experiences, the features, and the functions that we're conveying to you guys. And even with all of that, there's still more information that is left out, that we could be going into. And with that, I would definitely say, make sure to check out, the product pages on Newegg. Make sure to check out, our product pages, usa.asus.com. You can head over to edgeup.asus.com as well. We have a full kind of motherboard guide that breaks down kind of all the boards, their segments, their specs, a lot of the features, and also the comments. I'm sure you guys, if you guys have watched previous streams, I spend time to go back in there and take a look at your guys' comments and respond to as many as I can. So feel free. You can also check me out on Twitter, ASUS Tech Marketing JJ, send me questions, and I'm more than happy to try to give you guys insight into understanding what we're doing and help you guys make the best decision amongst this. But always great to be here, always great to check out about the boards and talk about a great platform launch.
Well, and we just love it here too, because we know, like you were saying, I know you've got another presser that you're going to go and hit like tomorrow, that you're traveling. This is your harvest season. Yeah. But it shows, like, these are the launches that get everyone in the ecosystem excited about competition, about better products, about evolution. And that's the time we really want to pin you down and get you out here. Yeah. We're really excited to talk about that stuff. So folks, there's going to be a ton of information. Helpfully, all of the links that JJ just went through, and then, of course, our product pages on Newegg.com. You want to stay subscribed to the Newegg YouTube channel. We've got Build Out X570 with ABS featuring an ASUS motherboard. Just saying, some good times there. You can check out some of our build videos there. I had a long sit down with some of the reps at AMD to talk about 3rd gen Ryzen, where I accidentally called it Ryzen 3, which was incorrect, and they were very polite in correcting me on that. And just later in the week, this Thursday, Trish is going to be back in studio. We're going to be doing another hosted Newegg Now, where we're going to cover the recent poll videos that we put out there for what your plans are for your next build, for some of your future upgrades, or if you're going to go Intel, AMD versus NVIDIA on the GPU front, how all of those pairings are going to fit together in your next build. We're going to be talking out your comments, sharing the results of those polls, so make sure you go and vote on those videos on the Newegg Studios YouTube channel. So plenty to talk about, so much more to talk about, because I feel, like I said, I'm going to keep coming back to that idea. This is going to be a fun product to watch evolve. As this pie hasn't finished baking. Like there's still more improvements and more performance to eke out of these parts. I'm really excited to see what we can do as we start digging into Ryzen 3rd gen. So folks, thanks so much for watching, for sharing, for subscribing to this channel. For Newegg Studios, I'm Juan Carlos Bagnell, and I will catch you all on the next video.